Good morning, ladies and gentlemen. This is Serena, your today's host for the conference. I'm a program manager at Platinum Global Solutions. It's a great pleasure for me to welcome you all at our Big Data eConference 2021. Thank you all for joining this virtual meeting, and I hope every one of you enjoying their best health. So whether you are attending this event for the first time or you have been a part of our top-notch conferences before, I'm sure that your experience at Big Data eConference will be worthwhile and productive. Our conferences have a reputation among delegates and suppliers as a must-attend event. I hope that the highly focused business development opportunities through the cutting-edge conference program and the numerous networking opportunities will all contribute to a successful and enjoyable event for you. So now I would like to warmly welcome our keynote speakers for today's conference, and I'll introduce you all to our speaker panel. Our first speaker is Akansha Bhagwani. She works as Solution Specialist Data Analytics at Google. She will be presenting on scalable software and big data architecture. Then we have Richard Engel, Data Protection Officer from Alliance. He will be presenting on big data and data privacy. Then we have Rajat Kumar. He's a senior data scientist at Ubisoft. His thoughts will be on great data quality is the shit. Then we have Ritesh Reddy. He's working as a senior data scientist machine learning at Grab. He will be exploring developing transformers-based model for text analytics. Then we will be having a 50 minutes networking break. Then we have Mofik Adi, the Microsoft Azure Data Scientist Associate from Ordo BHF. His topic will be deep enforcement, learning using big data for stock prediction,
which can fulfill all the requirements from data ingestion to data visualization and self-service analytics. I have a bonus link for you, which is the link to the white paper, which is called Bringing Data Lakes and Data Warehouse Together, written by some of my colleagues. So I will share it in the chat with you, so you have it. Yeah, and that's all that we have. If we go to the next slide. Yep. Thank you. Thanks a lot for having me. And you've been a great audience. If you have any questions, please feel free to connect with me.
Thank you so much, Akansha, for your wonderful presentation and for your time and effort you took to share your experience with us. Some of our audience have some questions and they have asked you in the chat. Can you please answer them in the chat?
Sure.
Okay, so thank you so much, Akansha. We are looking forward to work with you in our next conferences.
Yeah,
Stay safe.
thanks.
Stay safe. Bye. Hello, Richard. How are you?
Good morning, everyone. How are we?
We are good. Okay, so ladies and gentlemen, here we have Richard Engel. He's our next presenter who is working as Data Protection Officer from Alliance. And Richard, thank you so much for joining us. And we are honored to have you as our keynote speaker. So Richard, you can start your presentation after sharing your screen.
There you go. Hang on, should work.
Okay.
Well, can we all see that?
Yeah, I can see it perfectly. All right. Okay, so Richard, good luck. Stage is all yours now.
Awesome. Well, first of all, good morning, everyone. I hope that the weather is better where you are than it is here. I live in Manchester, and typically it is raining. It's what we call a British summer. So there we go. I'm glad to be inside talking to you all. Just a bit of background about myself. My name is Richard Engel, and I am a lawyer specialising in data privacy and data protection. I've been working in the legal sphere and data protection for about 20 years now, and I started my career in the ICO. Then I worked over to worked in the public sector, worked in local government, which is absolutely fascinating. And then more recently, I've moved over into financial services. In particular, the last sort of 2 years of my life, I've been focusing on quite a big data migration and a merger of various companies, because Allianz purchased Legal & General Insurance and LV General Insurance. So from a big data perspective, from a data migration, data transformation perspective, a really, really fascinating piece of work. Anyway, what I'm here to talk to you about today is around very big buzzword, big data. and basically more or less to look at what the legal implications of big data are. I'm not going to go into a huge amount of detail of the legislation. I just want to draw out some key themes, some key principles that you as practitioners should be thinking about when you are looking at what you can do with all this data that we collect these days on customers and from a range of sources, and the power of our analytics tools that are available to us. So I just want to give you what that legal framework is. I want to give you sort of a taste of some of the things you need to be thinking about and pointing to the right direction of people who are going to be your friends when you are doing this and will keep you out of jail. What a really good film here. Where we talk about, everyone's seen Jurassic Park, is that they go off and they use frog DNA and blend it with DNA from fossilized dinosaurs and recreate the Jurassic world. Great film, great idea, but predictably it all goes horribly wrong. And as Jeff Goldblum said in the film, your scientists were so preoccupied with whether or not they could, they didn't stop to think whether they should. And that's the same in big data. We've got so many opportunities out there in terms of what big data does, but it's really important when we start talking about personal data, and it's really important that we understand where privacy law comes from. I'm going to get really serious, actually. I like to talk about what I talk about. I like it to be light-hearted. I like it to be humorous. I think data protection is a really interesting area of law. It's why I've dedicated 20 years of my life to it. I'm an unashamed geek. But at the heart of it is a bit of legislation which is there to protect individuals, there to protect you and me, our customers, our citizens across the world. A lot of people forget this, but data protection comes from Article 8 of the European Convention on Human Rights, which gives individuals respect for his or her family life, home life and correspondence. It's what enshrined this right to privacy almost where it's come from. But people forget, so we do forget, that where the European Convention of Human Rights comes from, it comes from the aftermath, or it was born out of the aftermath of the Second World War, and in particular, the experience of German citizens under Nazi rule in the 1930s and 1940s. And we forget the role that technology played in the Holocaust. Some 6 million Jews, gays, gypsies, and other undesirables were murdered by the Nazi state. And we forget that actually the technology played a huge role in being able to machinize that process of state-sanctioned murder. And it is quite terrifying when we think about it. And post-Second World War, the European governments got together and basically said, never again. We need legislation in place. We need rules in place to prevent that from happening. And the Data Protection Act came out of that. It is designed predominantly to protect citizens from overmighty states. That was what the first two European directives about. And then the most recent one, European General Data Protection Regulation, recognised it's not just states that are the threat now, it's also multinational companies and big technology companies. And that's where we are. Big data, the technology we have available now to really, don't need me to go into detail of all this. You all know that you're all working it. You know, the volume and velocity of data which we can use and the things that we can do with it are a source of good in the world. You know, we can make better decisions. We can increase our productivity and our efficiency. We can reduce our costs. We can improve customer service. We can improve fraud and fraud detection, which in the insurance world is huge. You know, fraud costs the industry billions of pounds a year, and that's increased premiums for law-abiding citizens who don't commit fraud. So if we can use technology, we can use big data to match data sets to spot fraudulent activity, to spot and get criminal gangs that do it, to spot these fraudulent claims. We can actually reduce our insurance premiums for our customers and offer them a better service. So it's so much good that can come from it. But we have to remember there's an awful lot of bad that can come from it as well. I don't know if anyone recognises this chap in front of us, a gentleman named Christopher Wiley. He became famous about 3 years ago because he was the lead researcher for Cambridge Analytica. And he blew the whistle on their activities coming out of the American election 2016 and the Brexit referendum as well, whereby it was discovered that the Cambridge Analytica were using Facebook to essentially harvest the data of millions of US and UK citizens without their knowledge, without their consent, and was using that data in terms of micro-targeting. I'm expecting a lot of you will know all about this, to micro-target individuals on Facebook to give them very, very targeted and specific adverts. And what was so shocking about this was that no one had really thought about it. I'm going to put the politics to it one side. We're not going to discuss the Brexit referendum. We're not going to discuss Donald Trump. We're not going to discuss all that. We're going to give the normal lived experiences. Is that those people who had their data, who use this application, this application to answer a quick survey, a psychological survey, that were they told, were they aware of how their data was going to be used? And it wasn't just their data that was being used, is that when you signed up, it was a paid for app, you got paid a little bit of money for undertaking this research. But when you did that, Facebook was also harvesting, and therefore Cambridge Analytica was also harvesting all the contact details of your friends. So it's hoovering vast quantities of data and then making inferences regarding your likes, your preferences, what political party you might support, what your political opinions might be. It was quite shocking, really. And it was that scale and that lack of transparency which really sort of made people start to sit up and become aware of this. And there's a long-running series of legal battles regarding this, resulting in quite a large fine from the Federal Trade Commission for Facebook. So when we talk about big data, I'm a lawyer, so I'm predominantly concerned with the legal issues. So I made a little joke about the lawyers not concerned about ethics, but we are also concerned about the ethical issues of big data, and that's the lawfulness, transparency, and the ethicalness of what we are doing. So today we're going to unpick some of those principles and draw out some key golden rules for you to follow. I'm conscious that I haven't got a huge amount of time. This is a subject I could talk about on for an awful long time. So it's going to be a really, really quick whistle-top tour. And then obviously time for any questions afterwards. So predominantly I'm concerned with the GDPR. Any more in particular, I'm UK based, so I'm concerned with the UK GDPR following the exit from the European Union. The UK Union actually adopted the GDPR into its own legislative framework. So there's two pieces of legislation we're concerned with. That's UK GDPR and the Data Protection Act 2018, which was the implementation legislation. But generally, we've also got adequacy decision now, so we can share data around the EU. So I'm talking predominantly about the GDPR. I'm not going to go into specific regulations in too much detail. Because privacy law is growing throughout the world. The US, in terms of a lot of individual states, the US California privacy law, and a lot of individual states are beginning to develop their own off the back of the GDPR. And there are conversations in the USA regarding a federal privacy law. We've got India, got their own, Brazil, got their own, Vietnam, China, all developing their own privacy laws, which are all broadly along the right lines. So what I want to draw out here are key principles which you can apply across multi-jurisdictions. But essentially, I know the caveat to that is a top lawyer's tip here: always refer to your in-house legal advice for the jurisdiction you're in for specific legal requirements regarding to your jurisdiction. But generally, you follow my top tips, you're not going to go too far wrong. They're a really good start for 10. So what we're going to look at here, we're going to draw out first and foremost what is personal data. Are you processing personal data? Because generally, if you're not, hey, we step back and we go, wait, you don't want to talk to me necessarily. Always the first one. Then we're going to look at transparency and fairness, explaining how personal data is going to be used and whether it's fair and ethical. Then we're going to talk about on your lawful basis. Not saying no doesn't mean yes. What is consent? Consent is bandied around an awful lot. We're going to talk about a little bit about what consent is. We're going to talk about data subject rights. It's really important. You're processing personal data. It's really important to be aware of. The data subjects have very, very specific rights into their data. And then we're going to look at accountability, demonstrating compliance. What steps do you actually lawfully need to take if you are processing any personal data, be it 1 record or 1 billion records? The principle is exactly the same. So we're going to draw some of those out. I've got about 15 minutes to do that. So I'm going to talk really, really quickly. So bear with me. Right. So first and foremost, what is personal data? Personal data in a nutshell is any information which identifies a living individual. It can either be identified directly from that information or from anything else you can add to that. So a really good example, like a national insurance number. If you're the Department of Work and Pensions, you can link, somebody back to that national insurance number. A national insurance number is going to be personal data. You've got the obvious ones. You've got your name, address, postcode, date of birth. All these things identify us as individuals. But it's really interesting about this because we're not just necessarily about those identifiabilities. Sometimes anything which makes me stand out as an individual. And it's really important to note that you might strip out lots and lots of personal data. You're thinking, I've anonymized that. But as a data subject, I might come back to you and give you some other information which allows you to link that data set back to me. So anonymization is really, really, really difficult. Really genuine anonymization is really difficult. We're talking about AI, talking about training your data. You need to be thinking about is that data you're putting into your algorithm, into your system to train it, to do the work you want to do. You want to be really, really careful to make sure that what is the nature of that information you're using? Is it genuinely anonymized, or is it still going to be personal data? And say if you're just doing astronomy, if you're doing astronomy, weather watching, anything like that, then of course you're not going to process any personal data. But if you're trying to establish what your customer preferences are, you're working for a big bank or a big supermarket, and you want to crunch all those numbers about who's been buying cornflakes, who's been buying shop brand cornflakes, then you are going to be likely processing personal data, and you need to be really clear about whether the outcome of the exercise you're doing is going to be making decisions which are going to be impacting on the individuals, going to be identifying individuals. Are you making decisions regarding their creditworthiness? Are you making decisions regarding whether to direct them to a particular brand of cornflake, or perhaps recommend they buy Rice Krispies instead? Who knows? So it's really, really difficult to genuinely and truly anonymize data. So you always need to be aware of that. But say if you're just processing information about the weather or the stars, I'm not interested. If you're doing anything with any kind of customer data, personal data about subjects or citizens, then you most likely need to be thinking about the data protection legislation. Normally, if I was talking about this, I'll be asking you for any questions, obviously, as we go through. Can't do that. I like my presentations to be interactive. I like you to be able to ask questions as they come along. Can't do that. So obviously, if you've got any questions as we move through, pop them in the chat, and also I'll come to them later. Mentioned earlier about what we want to talk about. We want to talk about sort of transparency and fairness and ethicalness of processing. And this is really, really crucial. We're talking about fairness. Fairness first, because it's really difficult to define about what is fair. It's intrinsically linked to transparency and ethics. Was Cambridge Analytica's use of data, was that fair? Difficult to know. Did it lead to any unwarranted damage or distress to individuals? I personally, I don't think I was impacted in that. I don't think my data was collected as part of it, so I can't answer that question. But actually, if you are genuinely using information in a way which is beyond an individual's reasonable expectations, if they would not reasonably expect their data to be used that way, then it's likely to be considered to be unfair processing. And how unfair it is, that sort of scale of unfairness is obviously going to be, is a scale of, there's minor unfairness, there's no real impact on the individual, to really huge impact, where it leads to serious unwarranted damage or distress in the individual. If you are turning them down for a credit application, a job application, a university application, because of how you process their information, you're prosecuting them. Unwarranted damage or distress. You need to bear that in mind, about what is fair. There's also a flip side to it as well. We can get a caveat here, which is really small print. We can sometimes get bogged down in the small print of data protection compliance. And sometimes, data protection doesn't specifically prevent you from data sharing, doesn't prevent you, doesn't mean it says you can't analyze and data match big data. So we're predominantly focusing here on circumstances where there is an unfair outcome. Sometimes you want to do something that's good for a customer. And there's a slightly different assessment you might want to take there, because it's you might want to look at the outweighing the risks. But I'll talk about that a bit later on. But generally, if you are you've collected your data set, you've got an idea in your head about what you want to do, be it fraud, be it increasing the sale of Rice Krispies, be it looking to monitor emissions or look to monitor the movement of the stars. You've got an idea in your head, you decided it's personal data, it's not personal data. Is what I want to do fundamentally fair on individual? What are the ethical issues on here? Is this going to lead to somebody suffering a harm or something they wouldn't expect their data to be used for? We're going to have that in the back of your mind, because generally, the greater the level of harm, the greater that level of intrusion you're going to have on a data subject, the greater level of transparency you need, the bigger effort you need to take to demonstrate to individuals about how you are going to process their personal data. And it's a key requirement of the GDPR is that the data controllers publish a privacy notice, and they provide that privacy notice to data subjects. And that privacy notice needs to clearly explain to data subjects how their personal data is going to be used. It specifically requires you to identify you as a data controller. It specifically requires you to tell data subjects what their rights are in regards to their data. It specifically requires you to give you contact details of data protection officer if you've got one. And in particular, what data is going to be used for, what your lawful basis is for using that data, how long that data is going to be retained for. As I say, the more intrusive what you want to do, the more detailed that you want to do, the less that's beyond an organisation's reasonable expectations, the more detail you're going to need to provide. Sometimes it's going to be clear and obvious. I work in the insurance world. To what extent do I need to tell an individual that, of course, I'm going to use their data to be able to service their insurance contract? But I don't need to go into the in-depth details of policy administration necessarily. But I do need to tell them I'm going to use it for prevention. If I'm going to share their data with other insurance companies, with fraud prevention agencies, that's not within their reasonable expectations. I need to tell them that. It needs to be called out specifically in our privacy notice. And in particular for big data exercises or whatever, when you're looking at crunching data from a wide variety of sources, what you have to bear in mind as well is, where have I got this data from? If you are not obtaining it directly from the data subject, you have to think about, well, I'm receiving it from a third party. What has that third party told the data subject about how their personal data is being used? Is that third party even aware that I have that personal data now? It's a big challenge in the insurance industry when obviously we have underwriters, we have reinsurers, we have brokers, we have third parties. Trying to get that transparency of that data transfer is really difficult. But if you're working for an analytics company, Cambridge Analytica, for instance, did the data subject who was giving their information to Facebook, to this app on Facebook, were they aware that it was being received by another company over in Canada or in the UK? Were they told that? Were Cambridge Analytica giving them that information? Now, I can't talk too much about Cambridge Analytica as an example with the GDPR, purely and simply because it was pre-GDPR. It was all done in 2016 before the GDPR came into force. But we have a couple of more recent examples of this. One really good one is Experian. In the Information Commissioner's Office in the UK, began to look at what we call data brokering in the UK. The credit reference agencies collect vast amounts of information from individuals and they monetize it. They sell it. They use it for marketing purposes. I say to insurance companies for underwriting purposes, for demographics and postcode data. As individuals who sometimes you've got no choice but to have your information provided to a credit reference agency, you've got no choice because A, you have to apply for credit, B, it's usually based on the electoral register, which they have a statutory duty to provide information to. Are you told, were Experian, TransUnion Credit and Core Credit, and Equifax, were they telling customers about that their information would be resold for marketing purposes? The answer was no, they weren't. And a whole host of the ICO did a really big investigation into how Experian in particular, to how these agencies were reusing this data, secondary uses of data, and they came to the conclusion that quite simply they did not have a lawful basis to undertake these exercises because they weren't telling customers about it. They weren't telling data subjects their information was going to be used for marketing purposes and giving them the opportunity to opt out. They weren't telling customers that their data was being packaged up and aggregated and used for statistical analysis and sold onto other companies. They had to go and do an awful lot of work. To improve all their privacy notices and making sure that customers, that their data subjects, and they were getting information from third parties sometimes, their data subjects were given privacy notice about how Experian were going to use their data. So the ICO served them with an enforcement notice, which gave them until June 2021 to basically remedy the situation. So we watched the space with a certain degree of interest here as to what the ICO will do. I suspect it's going to have to wait until next year because Elizabeth Denham's leaving and there's going to be a new commissioner joining in October. But watch this space. If Experian have not remedied the situation correctly, they are going to be facing a fine of potentially £20 million or 4% of their global turnover. I'm not really going to talk about enforcement in this presentation, but those are the penalties we talk about with the GDPR. It is huge, a huge amount of money. We're into hundreds of millions of pounds. So it's serious business getting this right, that golden thread of data to you, and you're explaining to that customer how you're doing it. And then say the CNIL in France also fined Google for failures in their privacy notice. Simple fact of the matter is, it wasn't detailed enough. It was difficult to navigate. The language they used wasn't clear. You had to go to hundreds of different places to try and find that information. They find them, I think, 45 million euros off the top of my head. It was a significant amount of money. And the other day I was trying to negotiate Microsoft's privacy notice to give some advice to a client, and it was quite frankly, honest with you, impenetrable. And I'm a knowledgeable user of these things. So we always need to be thinking about that transparency. Are we happy to explain to individuals what we are doing with their personal data, and are we actually doing it? So we mentioned about lawful basis. I mean, this is really important. All processing of personal data has to have a clear and documented lawful basis. Now, what I'm talking about here is I'm not talking about special category data, which has an even stricter one. I haven't touched that subject yet. Just quite frankly, haven't got the time. But if you're going to rely on consent, it's got to be express. Can't be tacit, can't be withdrawn. The chances are you're probably not relying on, for a big data exercise, a big number crunching analytical exercise, you're probably not going to be relying on consent. It's not the most reliable one because consent is expressed and can be withdrawn at any time. Chances are you're going to be relying on, if you're in the private sector, you're going to be relying on legitimate interests, i.e. it is in your legitimate interests to undertake particular activity and to do so. It's a balancing exercise. It doesn't outweigh, your rights and freedoms of a data subject do not override your legitimate interests. Mentioned fraud earlier. It is our legitimate interest of an insurance company to process personal data for fraud prevention. That's what it is. And you weigh up the right of the individual, how intrusive is that processing with the benefits that we get from an industry perspective, the industry get, but also the public interest in that as well, as in talk about crime not paying. Once you've decided you're going through your exercise, once you decide on your lawful basis, you can't change it halfway through. So it's really important that you consult with your key experts. You decide what your lawful basis is, and then you document it. We refer to that D word later on, documentation. It is so important in data protection these days. A real big change in GDPR, documentation. So yeah, if you are going to be using special category data, and what that means, sort of medical records, ethnicity records, criminal records as well, data like that, then obviously you can't rely on legitimate interests for your processing. you're more looking at legal obligations, vital interests of a data subject, substantial public interest, and they are just far more difficult to justify. So we'll talk on that a little bit later. Talk about individual rights. If you are processing personal data, you've got a weather map or your stars, you're not interested in this, but if you've got me and my purchase of cornflakes and Rice Krispies in your data set, then this is important. Can I still be identified from that? I have the right to have access to my records, a copy of everything, right to subject access, the right to be told what information you hold about me, to receive a copy of that information, and to be told where you got the information from and who's disclosing it to. In the insurance world, that's fairly easy. You know, I've got a policy administration system, off I go, there we go. But if I'm doing a number crunching exercise, if I'm taking my customer data and putting it through a fraud prevention database, or I'm trying to work out what everyone's favourite pet is, in my pet insurance database, I want to run a statistical exercise on that. I mean, the most popular pets and what type of insurance and what claims I get on that. I want to mix my claims data set, my quote and buy data sets together with, you know, people who buy Rice Krispies. I'll go and buy some Rice Krispies data. You know, can we still identify individuals from that data set? Or is it truly anonymous? Because, you know, if it's not, then I still have the right of access to that data. I want to see whether you've got data from Tesco's that says, I've got a dog, I also like Rice Krispies. Individuals also have the right to have their records erased, the right to object processing, and these are really important. If you've got relying on consent, obviously, and someone objects to the processing, that's withdrawal of consent. It's where you're relying on legitimate interests. You don't always have to exercise an individual's right to transparency or right objection to processing if you can demonstrate that your legitimate interest overrides their rights and freedoms to have their information deleted. So I'll come back to, you know, for instance, fraud processing. You know, someone goes, you're processing my personal data for fraud, or you're prosecuting me for fraud. Please delete my data. What do you think the answer is going to be there? No. You know, it's don't commit fraud. That's kind of obvious, really. So it's always about understanding that. Always being aware that, you know, when you're creating your data set, when you're crunching your numbers, you know, you're training your AI, whatever it is you are doing, that if an individual is identifiable from that information, they can be singled out, then you might have to be prepared to comply with these individual rights. So your system should be being designed. You know, when we talk about privacy by design, should be designed to be able to exercise individual rights. You should be able to delete an individual record from your database. You should be able to extract an individual record from your database to give a data subject a copy of it if required. So always be mindful of that, conscious of the time. Talk about accountability. Now, arguably, this is the most important aspect of the GDPR. Essentially, it's like a maths exam. All data controllers need to be able to show their working out. Previously, under the old data protection regime, you were compliant until you weren't. That makes sense. You know, you quite merrily going along, and you know, you then have a data breach. And if that data breach, you end disclosing, I don't know, for instance, 500,000 customer records on an unencrypted disk getting lost between a courier and another office. You know, that's a breach of the Data Protection Act, and that was non-compliant. But in the old legislation, you'd always been non-compliant, but it wasn't a breach. Now it would be, because you've always got to show your working out. You've always got to be able to document what you are doing, document the security measures you've got in place, be able to document the decisions that you have made in regard to that data. Usually, you have to document that if you're doing a big data exercise, you want to do a fraud prevention exercise, you want to do an analysis of people who eat Rice Krispies. From the word go, you should be documenting what you are doing on that exercise. Talk about privacy impact assessment. Number one, you're doing a privacy impact assessment. You are sitting down and going, well, am I processing personal data? Yes. Am I doing anything special or innovative? Am I using new technologies? What's the impact going to be on individuals? What's my lawful basis? Yeah. Do I have a transparency? Do I have a privacy notice in place which allows me to do this? You're thinking about it from the word go. You're documenting it properly in your record of processing. The GDPR requires you to maintain a list of all your processing activities. It's quite a specific list. Say you're documenting every stage of your decision-making process, from the word go, from the idea all the way through to its conclusion. You are, if you're doing a privacy impact assessment and you decide that you're using a new technology that's going to impose a high risk to the rights and freedoms of data subjects, then you need to be doing a formal data protection impact assessment, different from a PIA. This is a statutory requirement. You'll be seeking the advice of your data protection officer as to whether you can even do this exercise. And if it's really serious, if it does involve large-scale processing or special category data, you're probably undertaking some kind of prior consultation with the supervisory authority, the ICO, who will go, yes, no, you can do this with these caveats. That's really, really important, but documenting is so important. Document. Everything you should do should be documented. Mentioned about having a data protection officer. Now, a data protection officer is a specific requirement of the GDPR, but not every data controller needs to have a data protection officer. Essentially, what the GDPR says, you need a data protection officer if you're a public authority, or if you're processing, if you're doing large-scale monitoring as your core activity, or obviously you're processing special category or criminal records as your core activity, you need to have personal data. But what I would say, and I would always strongly advise, that if you are any kind of organisation which is processing a large volume of customer data, individuals' data, it's a good opportunity to have someone who is designated your DPO anyway, someone who is an expert, an SME on data privacy and data protection, because quite frankly, honestly, they will stop you from being fined. Because if you haven't got the expertise in the business, that's someone who can independently evaluate that what you are doing is lawful and compliant and ethical. You are likely to be starting yourself into some rocky waters. As I mentioned before, a good privacy impact assessment, good consultation with a data privacy professional are going to allow you to identify the risks in your project and to take appropriate mitigating actions. Sometimes it might be you can't do it. You need to stop doing this, go back and revisit all your privacy notices, all your transparency notices. You just haven't got that lawful basis. You're not telling people you want to do it. I don't like being a computer says no privacy professional. I like to be constructive, and most privacy professionals that I work with like to be constructive in our advice. We're not being blockers. When we say take a step back, there are no shortcuts, we mean it. There are no shortcuts to it. Sometimes, as experience has demonstrated, you want data at the heart of your business. You've got to make sure the foundations and the building blocks are there for correct. Your privacy notice, your transparency notice is spot on. You have a clear accountability for data privacy in your organisation. There is someone senior in your organisation who has oversight of what you're doing. It's really, really important. I can't stress how important that is. This is where a lot of organisations are going to get caught out, is just not having the appropriate documentation. You have to demonstrate that accountability. So finally, conscious of time, 10 minutes over, the key golden rules, the things to take away from this one is be transparent. Explain to data subjects what you are doing and why. Be ethical. If you're not happy explaining to a data subject what you're doing, then possibly you're doing something you shouldn't be doing. In the insurance world, I'm always happy to pick a phone up, speak to a customer to tell them what we are doing, even when it's uncomfortable, even when it's difficult. Talk about frauds, people don't like that. I have to explain why, though. It's not fundamentally unethical. It doesn't make me uncomfortable. There are wider benefits. But if you're doing something that makes you feel insecure, and I'm not entirely sure we should be doing this. The implication has the data subject, the outputs of this leads to unwarranted harm. Are we going to be unfairly targeting individuals? Possibly something you shouldn't be doing. So seek advice, engage your privacy and security professionals early, on often, and listen to their advice. They are there to keep you out of prison. They are there to stop the big fine. They're not there to get in the way. Okay, their advice tends to be constructive, and they would encourage you. There are no shortcuts to this one, but you get those fundamental building blocks in place. As I say, Data Protection Act doesn't stop data sharing, doesn't stop big data matching exercises. It just says if you're going to do it fairly, do it transparently, do it ethically, make sure individuals' customer rights are met. So you might have to go back to basics and just review all your privacy notices. Document everything. I'll say again, documentation. So important. Engage your senior stakeholders. Make sure there is a senior executive level of oversight of what you are doing. Make sure that there's executive oversight of data privacy in your organisation. Talk about having a DPO already. Make sure there's a culture of no surprises, because the book's going to land at their door. They're going to have the one that explain to the board or the shareholders why they're facing the hefty fine, but you're not going to be there to do that because you're going to be at the door, being made redundant. You know, that's simple. So culture, no surprise, make sure that your executive committee, your executive boards know what you are doing, know what the outputs, know what the risks are. Real, hard-nosed risk assessments are really important in this. Use guidance that's out there. The ICO developed a really good range of useful guidance around accountability and using AI and all that kind of good stuff. Go and read it. It's on their website. And a lot of the data protection authorities in the EU are doing the same. For those of you who speak French, the CNIL is really good. They've got some really good stuff on this one as well. So it's really, really well worth the rule. And then finally, my golden rule, and I say this to whenever I do any training in-house, when I'm doing any external speaking, if in doubt, shout it out. There's no such thing as a stupid question. If you think something's not right, if you're not certain about something, go and have a conversation with your privacy professional. If you think your organisation is doing something that is fundamentally unethical, have a look at your whistleblowing policy. You should have one. These are the things that we're concerned about. We look at Christopher Wiley, we look at Cambridge Analytica, and he ultimately felt deeply, deeply uncomfortable about what was happening in his organisation, his culture. I heard him speak at a conference a couple of years ago, and he said, I was working for this company doing really cool data stuff, and he actually loved it. All of a sudden, a lot of former Russian secret agents started working for them, and he felt deeply uncomfortable about the direction the company was going and what it was doing. So the ethical concerns about what we're doing are really, really, really important, and we all have a role to play in that, about making sure that we keep big data sharing, data analytics, so that we keep it clean, ethical, and we deliver good public good. Well, that's me. Thank you very much, guys. Look me up on LinkedIn if you want to. I'm happy to answer any questions or any queries. I've seen there are some things in the chat, and I'll have a look at those later. Thank you.
Thank you so much, Ajit, for your wonderful presentation. It was really very informative. I personally enjoyed it, and you have touched so many critical areas. So thank you so much for your time and for being a part of this conference. We are looking forward to work with you in our next conferences. And I'll ask the audience that if they have any question, they can ask you in the QA session.
Cheers. Yeah.
Okay. Thank you. Have a great day. Bye.
And you too. Thank you. Bye-bye.
Bye. Hello, good morning, Rajat. Hi. So I cannot hear you.
Hi. Yeah.
Hello.
Now
How
is
are
that
you?
fine?
Yeah.
Yeah, I'm good. How are you?
I'm good too. Thank you so much for asking. Ladies and gentlemen, now with us is Rajat Kumar, and he's our next presenter. He will be speaking now. So Rajat, you can start your presentation now and by sharing your screen.
Sure. So yeah, let me go. Hello, everyone. I'm Rajat Kumar. I'm data scientist. And today I'm going to talk about data quality. Yeah. Let's then start with it. So with this, what is the first question which comes to our mind? What is data? So what is data? Data is a unit of information. It can be a qualitative or a quantitative. And okay, now we know what is data. Then what is data quality? Well, data quality is some sort of a health of the data in the whole organization. It's not a low or high. It's like a range or a matrix or a measure which defines how well the organization as a whole does in terms of the data. What is which is our main topic, what is data quality management? Well, data quality management is a process which is context specific, which helps in improving the data quality throughout the organization. So it's more like a strategy. So with that, let's get on with So we start with an example. This is a small subset of some data source I mocked up earlier. So here we want to see what are the possible data, some of the common issues or possible data issues we face in day-to-day's general discovery as a data people. So one thing we can start looking at when we start looking at the data we see is company name being General Motors Company, GM, General Motors, General Motor Corporation, and General Motor India. So all of these seem to be from the same company, but they have different company names. Next, when we look at the other records like phone numbers, contact person, contact email, country, record date, and pin code, I mean, most of our data sets are similar, looking at it with different fields having different informations for the record. So if we look at phone number, we see various types. Somewhere there is a state and a country code, somewhere there is none. And some of them have symbols, some of them do not. Eventually going forward, even in contact person name can be the first name, can be the first name, last name. It can be a combination. Then next is contact email ID, email address, where we can see there can be problems with, having some sort of website or personal email addresses, which is a common issue for the data quality. Country names can be varied, although the country name is, I mean, it can be standardized, but while doing a data entry, it could become a problem. And, like example, like U.S.A versus USA. In the data context, when we try to analyze the data, and we are trying to see if by country how much of revenue is generated or what is happening in per country, then obviously the USA and U.S.A is going to be a separate thing unless we fix that data issue. So yeah, the next thing is a record date or a date when this record was inserted or something like that. Here we can see a missing data and some of the errors in the record, like there's a very futuristic date or there's a date which is very, very old. Lastly, it's a pin code address or a pin code. So this is just a demonstration I wanted to show first. What does the real data issue looks like? A very common one. So as we spoke, this is mostly a naming convention. It is not standard. It is, for instance, for country and the company name. So we will talk about how to fix these and how to have methods which can automatically fix these. But first, let's look at all of these. So here we are looking at the bad formatting and the numbers not standard in the phone number. Next one, we're looking at the website is entered, www.gm.com instead of the email ID, and also a personal email has been given. So a personal email might be okay, but the person can move on in a couple of years from one company to other, and then we may lose the information about the person. So yeah, the company. So that's something we should take care of. Next one is we see a lot of missing data and missing values. This can be a problem, especially where critical records are being looked at. So one thing to note is it may be okay for some of the fields not to have some data, but for some fields like record date or contact email address and ID or phone number, maybe it's a critical data for our data source or our database. So it's not good to be missing this data. And till now we were looking at individual level. One example for overall record level is first looking at the erroneous data, which is an error in the data itself, which is too futuristic or too old. It's not possible to have a data from 01/01/1901 or 31/12/2099. So these are some checks which could have taken place, and we could have stopped by having, we could have avoided these data issues. Finally, we look at two records where we see that Tom and David are from the same company, having same phone numbers at the same country, and the pin code is also same. So are there two POCs for the same office in the same number, or is there a problem? So even at the record level, we can look at what are the problems exist in the database. So some steps to avoid these common data quality issues. First one being data entry standard can be, there can be a standard for the data entry. So for instance, for the fields like email, phone numbers, there should be a standard setting that at least this is required, a area code is required, a country code is required, and then only there should be these many digits for the phone. Email addresses can be like, you have to have few characters and at the rate and then something dot something. So all these rules can be defined, and there can be a, data entry standard can be set. The next thing is important fields can be marked as not nullable, or they cannot have a null value. They have to have some value inside. So by doing that, we'll know that, because some of the records will have no meaning. For instance, if this is my customer database and I only have the, a point of contact name, but no phone number or no email, I have no way to contact that customer. So it's good that we don't have that record itself if we don't have the contact information. So there are some fields which are very important, so they should be not nullable. And if someone is trying to enter a data with this problematic values, they shouldn't be allowed to enter this into the database. And next thing is, instead of allowing free texts for everything, for instance, what we are seeing in country or company name, this is free text every time someone enters a new name. For instance, u.s.a instead of United States of America, it's going to be creating a new country kind of a thing in the database, which is not good for our data, and it will be an issue for us. So instead of allowing that, we can have a drop down kind of a field where you can select which country you want to enter or something like that. So that will help us eradicate these kind of issues. And next one will be, we can have some sort of checks that will look at things like extreme date, extreme values. For instance, if there is a transaction of $50 million where we usually see transaction of $2,000 or $3,000, then there's a error there. So it's better looked at. So there can be ranges set that it cannot go beyond this. For instance, in terms of date, if the database may not allow something for the future date, sometimes for some teams, for instance, sales or even funnel teams, they say that in 6 months in future this customer may buy, so they want them to be have a future date. According to the business need, we can set certain rules, and beyond that, the database should not allow someone to enter. So these are all business decisions, can be made by business analysts or the business stakeholders. Lastly, I'll say rules can be defined for every set. For instance, for Tom and David case, that if there is one company and one POC and one phone number and things like that, then they may not be two names, or there can be rules to merge all these things together. Okay, if there is contact person 1, contact person 2, or things like that, so that we don't have duplicates. For instance, like we see the point of contact and other things. One thing to emphasize here would be IT department may not have enough context to fix all this data. A lot of times management or people in other departments feel that this is IT's job and they should be doing it. But we need to understand that IT department just takes care of the data, or makes architecture, or makes the pipelines for the data. They may have no idea, they might not have any idea about what this data is and what's the context behind it. So before going to anything, let's first look at what are the benefits and what are the impacts of data quality. First being the benefits. So the first benefit being decision making. So if there is a higher data quality and the management knows it, every time there is a insight coming out from the analysis or from the from the statistics shown by analysts, business will feel comfortable in making decisions. And if the business knows that this data, our data quality is not good, the systems do not talk to each other well, then people will always, the management will have a doubt making a decision with the analysis done. So bad data is going to be it will be very hard for the management to make a decision. So as the saying goes, garbage in, garbage out. The reverse is true as well. So if you have good data, there'll be good insights out and it will be more reliable. Second thing is productivity. Every time there's bad data, for being a data guy, we have to spend a lot of hours cleaning it. We have to spend a lot of hours verifying it. So it's a huge productivity loss, and it will lose us time and sometimes can lose us business as well. Third is compliance. In this era, which is the data era, relationships are governed on regulations. So if something not good happens or something like that, if there is something to do with compliance, then it will be very bad impact on the business. Lastly, it's marketing. If we don't have a good quality data, then we may miss targeted marketing, or we may miss the right communication, especially in the omni-channel environments. Next is similar to benefits. There are impacts if we don't think of data quality early enough and start working on it. First is undermining the confidence. Exactly. If we have good data, we have more confidence on the decisions and on the analysis shown or observed in the data. If we have bad data, we have less confidence and less trust to make a decision. Next one is missed opportunity. If the competitors are more data driven, they have better insights and they can move faster, and we may miss the critical opportunities. Based on this bad data quality, we may even start losing revenue. And lastly, the reputational damage. One thing to understand is it may not come as a one day problem. It may happen every now and then, small, less significant, that people would not, or the business would not even understand that they are facing some reputational damage because of the data quality issues. One of the major reputational damages, as an example, is Apple's widely planned map out now in 2012, which had data challenges. So it was not a very successful thing. Next is would like to talk about data quality dimensions. So now we know what is data management, data quality, and data quality management. So first, what should be the dimensions? How do I look at the data? So the first dimension we'll talk about is data accuracy. It's how accurate is the data, and next will be data validity. This talks about mostly how valid this data is. So for instance, if this is collected in the right format, for instance, if this is allowable format or not. Next dimension would be data completeness. If this data is complete, for instance, as I gave example earlier, if there is no phone number or contact email, then there's no way of, and if this data is for the contact, for a customer contact data or something like that, then this data is not complete at all. And the next dimension will be timeliness. So this is very critical in terms of every going day and every going month, the data becomes older, and as the data grows, it becomes almost bad. So we need to keep a track of the timeliness. When was the information collected? When was this data collected? And could this be right or not at this moment? So for instance, if there's a customer data, one particular customer whose information I have from 5 years ago, it may not be right currently. So may need some sort of verification or update. Next one is data relevancy. So for instance, it's very important that the data we collect, we store, and we try to spend so much effort in cleaning and doing everything is relevant to our business. It cannot be that you are collecting some data which has no relevance to your business or very less relevance to your business. An example I can think of is like a bank trying to collect health records of their customers. Not so much good can come out of it if they try and do this. First, why would they need it in the first place? Next one is uniqueness. So this is more of if the records are unique, I should not have multiple records having same information or conflicting information in the, better words to put, if there are conflicting information and I have 2 numbers or 2 emails or 2 names for the same contact POC or something, it may not be a good thing, and it would take time for me to make a decision, or you have to go for a trial and error to see which is right. Next one is data consistency. This is more about if there are 2 departments, 3 departments, they have their own data sources. One department's data source says X and the other department says Y or Z, then there's going to be conflict when there'll be a centralized data system. And if someone wants to do an analysis, or if there is some insights to be derived from this central database. Lastly, privacy, it's very important. So our appropriate permissions acquired from the customers or from the people we have acquired this data, it's very important for us to know, and it's very important for the customer to know how we are going to use this data. Next one is, now we know the dimensions. Next, let's set our our pace to how do we quantify it. First thing we need to set is what are these few roles and ownerships before even we start. How do we quantify it? Things like data owners, data stewards, data custodians, and data curators. These roles may vary with domain, function, and system. So just to brief about what are data owners, these are people who are accountable for the data quality. They decide who have the access to view the data. So they are mostly the senior business stakeholders. Then next comes what is data steward. These people, they create the rules to govern the data. They are the people who are going to create rules of, this email can go in, this is the format, and things like that. So they are mostly the, they are people who create the rules, and data owners are the people who will approve these rules. They'll say, yeah, this fits the business needs and this is right. Next one is data custodian. I'll say data custodian as more of an architect, IT guys. They are very technical, and they know about the database and the data structure and architect levels. So yeah. Last one will be data curators. They are not more of a data management people. They're more of a data metadata management people, more like a data dictionary. So they look at the context of the information. So these are the people who are more of a domain guys. So after we have assigned these roles, second step would be to and set our or fix our data dimensions, data quality dimensions. For instance, now we were discussing about accuracy, completeness, validity, uniqueness, and timeliness. So, and other things. So we have to set in our organization which are, critical dimensions for us to measure on. Third step would be to size the problem, looking at all the data we have in the organization in different departments and in different data sources. How do we quantify it? There are few ways of doing it. One is one rough example, mock-up example I'm showing is a spider web diagram. Other could be like a heat map, looking at various departments and various dimensions, looking at the heat map, seeing which are the problematic area. So, after testing all these, for instance, in this mockup, what we are looking at is all the three different departments having service desk, supply chain, and factory production. How is their accuracy, accessibility, and so on and so forth. What we start observing after doing this analysis is there's a critical problem in the data completeness dimension. So this gives us a quick start at where do we need to start our investigation, or where do we need to start investing more resources on. So as this mock-up diagram shows that this data completeness of all the departments have very low value, and that's one of the major major issues in the organization. So yeah, we can start, and after this index and scores are set, then we can start working on each and every problem. One thing to note also is data cleaning and maintaining the data clean is two different processes. What we are doing, or what we are talking about right now, is like a data cleaning. How to keep the data, maintain the data clean is the next process after we have done all the cleaning, and after we see, because it's like if you have cleaned the house once does not mean it will remain clean. It will keep getting dirty. So you have to keep, this is a cyclic process, and you have to always look through it and go step by step. So next, let's go to what could be the steps, some template steps of how do we, if the organization finds out we have not good data, or we have bad data and the quality is low, what could be done. So we take raw data, and first thing we try to do is set data entry standards. So for instance, guidelines in starting place for the organization. So the email should be like this, these should be the things. we can only have a date which can range from this place to this place. Our transaction only ranges from this to this. So these are certain guidelines which can be that if you want to enter the data, these are the rules and regulations you need to follow before this data can go into the database or data warehouse. Next one is having option sets instead of having free text. So for instance, for the company name and the country name or other things where we can drop down and we can select which country and which company this is. Next one is determining the key data. This is very important because we may have a lot of data, a lot of fields and a lot of data sources. Unless we don't jot down to which are the more critical data sources or more critical data fields, we can't be fixing everything from the day one. So it's very important to determine the time and business critical data. There is data, if you give me after 3 days, it's of no use. But if you can give me today, that is almost real time, or a couple of minutes later is good, but after some time it's not good. So this is time and business critical data needs to be determined and needs to be worked on before going into any other subsection. The next one is having some address management tools if your data requires them. So for instance, we have a lot of third-party tools, or you can build in-house tools which can look at the address. So basically, there'll be less manual steps involved in the future, as well as when the data is being cleaned. So this address management tool will help set these addresses right, and they can check for rules. Next one is to detect duplicate and cure them. So for instance, if we detect duplicate records from which are we need to look at the business logic first. So and how do we prevent it, how do we correct it? For instance, do we need to merge these duplicates? Is there some critical information one of the duplicates have and the whole record does not have, the main record does not have? And if one can just be deleted. And so this decision needs to be made by the people who are going through this process. Next is the integration tool. This is more like a centralized place where all these departments come together, because they have things like customer IDs in common. They know when this was bought, when this customer has been served, and so on. So the integration make a centralized system so that these databases or these data sources talk to each other. So when a data scientist or a data analyst or a business analyst is trying to pull out a big information and not just a department level information, they're able to get this and then analyze it properly. The lastly, it is reviewing the data quality. This is an ongoing process. It's not a one-day thing that once it's done, we need not do anything for the future. So after set of reviewing quality and standards should be periodic. So every monthly, bi-monthly or something, there should be some rules, there should be some checks done on the data quality, so that we know that whatever measure we did and whatever improvements we did still hold. And after that, yeah, we can get clean data. Next one, these are certain directions. They may not be perfectly following order because some are interdependent on each other, but let's go one by one. Obtain management commitment to the data quality. I think this will be the first step, very critical, is to obtain the commitment from the management, because if they are not signing up, then it's very hard to take an organization on this data quality journey. But then how does management sign up unless they understand if this data is going to be of a huge asset? So yeah, the interdependencies kicks in. We need to test data as an asset and prove to them that if we have this information, we can do better, and our business can have better results. Next one, as we talked about, is we have to assign the dedicated resources like data curator and data owners and others. So there is no finger pointing that that department has to do this department has to do this, or all the work has to be done by the IT department. This is very critical for us to in initial portion assigning the roles of what one person or other person will be doing. Then building an explicit knowledge of the data to know about what is mostly like metadata, or what is what data about, and which systems has what data, and how can we have a centralized system. Then it's like secondly, the next thing is data needs to be a product which can be measured. So it can be measured and improved. We cannot say that, you know, this is all the data is here, so if 100% data is here, regardless of what is the quality inside, I'm going to say all my data is correct. So for instance, if there were 100 fields and 5 columns, and if I have 500 individual records, then it's done. No, it's not, because one is completeness and the other one is accuracy or quality itself. So it should be measured and it can be improved. Next is how do we, you know, define the data quality should be defined by the consumers. It should not be defined by IT people or people who are creating it. So it should always be defined by who is the stakeholders who's going to consume this data and then use it for their business needs. After all this, we need to have people who can do root cause analysis to address what problems exist. After the problems is identified, we need to measure it, like what we just did in the spider web diagram. What are the critical places where most of the departments are lagging behind, or is there one department which is lagging behind too much? What is the set standard and things like that. Next one will be data owners should be held accountable for data quality. It should not be the IT, it should not be any other team. It should be the data, you know, owners or producers who are held for accountable. If they are the entry guys, then data entry guys. If these are the people who are, you know, working on the manufacturing line or something, and they are, you know, pulling out the data or something, then they are held responsible. And next would be very important. When an organization is going through such a change, it should go through multiple trainings and the knowledge required for the data use. One is how to collect it, knowledge for that, and what could be the problems with the data, and what happens if the data collection is not right, and if the integration is not right. The next one is how do we use this data, and what do we use this data for. The next thing is, at this point itself, people should start planning for evolution. So for instance, right now I have all the data in a file format, in a text format. What if tomorrow a vendor or a third party or a customer comes and says, I have only data in the PDF format, or I have only in the text format or image format? How do you, you know, plan for it? So during this journey itself, you have to plan for an evolution. What are the possible next steps? And lastly, it's a culture. It's not a one-time process. So it has to go, you know, it has to come in the whole organization, and it's not at one place, one person, or at one department. Next one is organizational maturity. This also can be measured in some in some manner. So for instance, we look at this quickly as an organizational dimension of people, processes, technology. In technology, stores and storage and architecture can be looked at. Data asset can be looked at as value, innovation, and assessment. So how they're doing currently, are they like just beginning the process? Have they established the process, or are they managing, or they are optimizing the process? So what place are they on this journey? And eventually we can get the overall view of the organization. So these are some tools which can help in data quality. I like Informatica. I have used Informatica, Pentaho, Talent, so, and SAS also. So I've seen, and some of the relational and non-relational databases. So for instance, Teradata, Redshift from Amazon. So these can help in, you know, in the overall, because data quality is not one thing. It's about the architecture, it's about the whole process, the whole flow, and so on. So yeah. Hello.
Hello, Rajat, thank you so much for your wonderful presentation. And it was very productive and interesting session. We are happy for your contribution in our conference. Thank you so much, and looking forward to
Thank
work
you.
again. And I will ask the audience that if they will be having any question, they can ask you in the chat or QA session. Okay.
Sure.
Thank you so much. Stay safe. Bye.
Bye.
Hey, hi.
Hello.
Sharing my screen. Yeah, hi.
Hi, Ritesh. How are you?
Can you hear me?
Yeah, I can hear you. Can
Yeah,
you hear
I'm
me?
good. Yeah. Okay, so can you? Yeah, I can hear you very well. Can you? I've shared my screen. Is it visible?
Yes, I can see your slides
Okay.
now. Okay, so ladies and gentlemen, now with us is Ritesh Rathi, and he who is working as senior data scientist machine learning at Grab. So, Ritesh, I can see your slides perfectly. You can start your presentation now, and good luck. Stage is all yours now.
Sure. Thanks a lot. Yeah, yeah.
Yes.
Okay, so in this presentation, I would be discussing about the transformer-based models that have been or currently being used for text analytics specifically. So let's get deep dive into like how the evolution of unstructured data happens over the time period. As we know, like now most of the information that we have in is in unstructured format, whether it is image or it's text or it's a voice-based format that we have, and we as a data scientist will require to extract the couple of useful information from this unstructured data so that we can build our model and then can build our AI products on top of that. So over the period, if you see like the 1970s, we have very less data. Mostly we are working on the structured data, but over the decades, it has been increased up to 120 exabytes till 2020. We have seen a tremendous growth after 2000, and it has been exponentially increasing day by day. So with this, there is a requirement for, because most of the text that we have is in textual format. We will talk about like what are the different sources that we have available in case of text. So most of the data, as we have seen, like in over the websites, we have a lot of information available that belong to text. We have document management systems specifically for keeping the textual information, email IDs or the email content that we have. We have the data in our database storing in some textual format most of the time, and we have feed related data or the data that we got for customer reviews, or we have a huge content from the social media as well. So if you see like we have a disparate data sources. Now challenge is like how to build a text analytics solutions out of it. So what we do is like we follow a couple of machine learning pipelines wherein we define a problem. So once the problem is defined, like if we the problem definition says like I need to estimate um, the reviews, whether it's positive or negative from content for a particular content store. So I will define a problem, will collect a specific data set, and then for that data set, we need to prepare data in the required format. We need to prepare the data so that ultimately the textual information would be represented in the information which the model expects. So it could be a numerical representation that we can think of. So once we have that data representation ready, we will train our model. We will use couple of modeling techniques, get the model trained, and once the model is trained, like we need to evaluate how well we are performing on the real world tasks. So once the evaluation is done, we followed the deployment strategy so that we can use it in an online system and can improve it further. So this is the general machine learning pipeline that we used to follow for and building any text analytics related solution. So not on top of machine learning, there were different dimensions like natural language processing, image analytics, or we have a voice analytics features. So I would be specifically talk about like what is natural language processing means. So it's a process of analyzing the unstructured text, extracting relevant information from the linguistic or statistical techniques. It consists of two main branches. One is information extraction and another is information retrieval. Information extraction is meaning like we are extracting couple of relevant features from the text. It could be like what are the different topics associated with the text, or what is the term frequency or inverse recurrent frequency of the text, what is the summarized content that I can extract from the text, or what could be the proper groups that I can found out of the text. So information extraction provides us methods to solve this purpose. And next is information retrieval. Like we have a data set, huge data set. Now we need to retrieve all this information, the specific information, within stipulated time, and as soon as if possible. So we have a various IR based solutions available, like we have a Google search, which ultimately indexing the documents and retrieving the results back. So information retrieval, mostly people are using I information extraction based features that we have extracted earlier and have been indexed them for the retrieval tasks. Various applications that we have seen in natural language processing, as I talk about, like search and ranking, wherein you have the lot of information available and you need to identify the specific content, or you need to re-rank once you have the content, like which is most important at a particular moment or based on the contextual parameters. Second is question answering based system, wherein you need to find out the solution or the answer with the specific question. The question can be factoid type, or it can be a general question about some related event, or it's related to some person or something like that. So huge content is required to build this system as well. Customer reviews and feedback analysis, like this can be a very important utility for driving the business altogether, which can have a positive impact. Like we need to identify what reviews have been coming from customer, how my product is getting performed over the period, and we need to analyze the feedback, whether our customers are happy or not. So these kind of stuff we used to follow through surveys or something like that. Summarizing surveys, like if you have a lot of content and you need to know the summary of it, so text analytics solutions can help in identifying that too. Document categorization, this field suggests me, like if we have huge number of documents, like million of documents, I need to categorize a specific document into multiple different categories. Let's suppose if I have a legal document as one category, medical documents as another category, or sports related documents another category. So these solutions, the NLP based methods allow us to solve those problems as well. Machine translation, as we know, like we are moving globally, and we need to convert one language to another, and it's pretty much desired for most of the use cases as of now, to remove the gaps that we have in understanding. So machine translation solutions also have been built up recently with the help of NLP techniques. The couple of tools or technologies that we use normally are the Mallet, Gate. NLTK is the most common library that Python people or the developers use. OpenNLP is also one this that supports Java and Python based libraries. Transformers, Hugging Face provide this transformers library to use the transformers based models and apply transfer learning approach to solve multiple different problems. TensorFlow Text is another solution provided by TensorFlow library, wherein you can use the TensorFlow Text for defining your different problem domains and solving that through various multiple different technologies. So these are the couple of information that we have, like what is natural language processing all about. So as I talk about, like these are the various NLP problems that we solve. One could be part of speech, like if you have a text like she sells seashells on the seashore. Now what is she? So it's basically pronoun. Sells could be verb, and seashells could be noun. On could be or DT determinate, and noun as a seashore. So how we will be able to identify this part of speech tag, because these are the basic constraints for any language. So these kind of problems are solved through through NLP based solutions. And to solve that, like there are a lot of open source data available, the tag data that people utilize to identify various tags. Now, where we see the utilization of these tags. So one utilization is like it can act as a feature for a couple of other problems as well, and it can also be used for defining the dependency parse structure also. So couple of other problems that we have, I talk about the document categorization. So this is the subset of most prominent documents that we have, and we need to identify the technology, sports, or entertainment, this kind of document categorized into multiple categories. So text analytics solutions have been built on identifying that as well. Another big problem is like identifying the named entities that we have in the text. Like so there's a text like Elon Musk apparently was not aware of his company SpaceX at Facebook. So here the task is to identify the most prominent entities like person or a product or a Facebook or organization. So this kind of information, as we know, like is required because ultimately we need to build a kind of graph structure wherein we can associate each of different entities associated with different kind of verbs or different kind of association. So let's suppose Samsung and iPhone or Apple, Samsung or Apple, we have a competitor as a relation. So this is an example of for a relationship extraction. So what we have done is like for relationship extraction, to solve that problem, we might require the entity tags so that we can associate and use those as a feature to solve the relationship extraction problem. So another problem is like which is based on unsupervised methods of definition, like topic modeling, wherein you have a content or a text wherein you need to identify what topic it belongs to. So and we need like multiple different topics associated with multiple probabilities. So if a topic is like I like to eat mangoes and bananas, maybe it belongs to some topic A, which is could be a fruit as a topic. Another is the best place to see giant panda is China. So could be a topic is related to some travel related topic. So what we need is like most of the times we need to identify or extract the topics out of the text wherein we don't have an label data available. So there the topic extraction utilities and the algorithms helps to solve those purpose. Okay. So we have seen a lot of NLP related problems that are existing in the literature, and how to solve that in a general way. Like we use this traditional NLP pipeline wherein we have the text at available with us. Now with those text, first step we do is like tokenization. Let's suppose we have an English language. So what we do is like we expect that space will be separating all these tokens. Now next we will be doing some pre-processing over the text wherein we will remove the stop words like a, an, or the. It doesn't mean to include those words and in the machine learning modeling part because those are not getting any meaning out of it. So once those are removed, we are left with the limited number of words. Now those words we need to can be represented in various different forms. Let's suppose plays, like I play football, or couple of or I am playing a football. So plays and play and playing. So these are the some form of root word which is called play. So what we do is like we are reducing the search set wherein we have replaced playing or plays with play as a verb. So this part is taken care with the help of stemming and lemmatization based approach, wherein stemming is a rule based method with the fixed rules that have been defined. So what we have done is like we have pre-processed the text now. Now the next comes like once we have represented each of different words. Now for machine learning modeling, what we need to do is like we need to represent them in some vector form. So here feature engineering part comes, like we can represent each word using a bag of word techniques or the TF-IDF technique, or we can represent into vector form using word embedding. So these word embeddings, once we have represented the vector, like these vectors, we need to learn from our model. So model will take that vector and will do the model building part of it. And then once a specific, for a specific problem, once we have the model ready, we'll be finding the model evaluation step. So this is a traditional PanLP pipeline where the handheld features have to be defined. We need to define what features to be included and how they will be getting represented in terms of various vectorization techniques. And then these vectorization techniques will be ultimately be used to build the model so far. So here the main problem was like defining the features, because that may differ from for each different domain. So now the modern NLP talks about mostly avoiding those feature extraction part. So let us take one more problem that we have. Like one is sequence to sequence modeling. So what it talks about, like if I am modeling my problem as a sequence, let's suppose first sequence is some English language, which is a sequence of couple of words, and output I need is the French translation out of it, which is maybe or might be lesser or greater than words. So x1, x2, x3 could be I am playing, and y1, y2 could be the corresponding translation in French. So what people generally use is to define the problem as a sequence, wherein they will be using multiple different sequence modeling models. RNN is one of them. So they will be supplying the input to RNN. It is getting encoded into one intermediate representation, and using that representation, people will be predicting what is the translation all about in French. So the main problem was like the dealing with long range dependencies here, because the text could be longer than most of the 100 words it can go. And once we have a longer dependency, we might land into loss of information due to fixed length vector. This encoded vector is a fixed length. So when we are modeling the sequence model on the later stages, we might be able to losing the information here. So these two problems were getting solved through the latest transformer based model, wherein transformer based architecture has been come up. So what transformer is, it's a novel architecture to solve the sequence to sequence task while handling these long range dependencies, and it relies on self attention to compute the representation. So what self attention means, like in the previous problem, I am giving two information. One is English text and another is French text. So one is going to be a query and another is going to be a value that I have. So intermediate representation is represented in three vectors: query, key, and value. So with the query, key and value are the part of the input that we have supplied, and query is what I need to extract from that. So self-attention is computed multiple times in parallel. Multi-head attention, we call it as multi-head attention. So this is one figure represented as one layer of self-attention in the transformer model. And similarly, we have multiple different layers. So in one layer, when I'm supplying the input embedding, the position encoding is added to that, and then we compute couple of attention values using key, query, key, and value. We further attach it with feed forward neural network, which is basically representing the information here, and this information passed to a decoder. So this information ultimately be using with couple of more layers, and here we will be having a softmax layer to identify the probabilities or scores that we have got from out of the machine learning model. So what to, so these are a couple of pre-training tasks that these transformer models have been trained on. One is mask language modeling. What does it mean? Like, so suppose if I am having sentence like I am playing football. So what they do is like with some probability, they will mask out a couple of words and supply that to a transformer models to predict those words that we have already masked. So this way, mask language modeling works. In next sentence prediction, like suppose I have two sentences, I am playing football, but it is raining today. So with one sentence, they will be trying to predict the next sentence. The very good use case that we have seen for the next sentence prediction in case of Gmail or any mail utility, like we are typing one word and it's about to complete the next sentence as well. So what libraries people are using here is mostly the Hugging Face transformers and TensorFlow specific couple of transformer models like BERT is also available that can be used to define the problem for. Okay. So, so here I would be describing like what are the different text analytics problems that people can use that or use the transformer to solve for. So one is I talk about language modeling. Mask language modeling is wherein we are masking a couple of tokens in sequence with some specific mask as a token, and then we are asking model to fill that mask for the appropriate token. This is one. And another is causal language modeling, which is basically task of predicting token following the sequence of tokens. So in previous, we were not looking into the sequence of tokens that are coming, but in causal language modeling, we are taking consideration for that. And next token is getting predicted by sampling of logits of last hidden states. So these causal language modeling is mainly used in GPT model. So the GPT model are the transformer models provided by OpenAI, and so these are being used for specific purpose. So far, in sequence classification is one more task that can be performed, like classifying sequence according to given number of classes. Let's suppose if I have a sequence classification problem wherein I need to identify the reviews, like whether it's a positive, negative, or a neutral. So here I would be looking into the sequence of words that are coming into sentence. So one sentence could be like I am feeling bad about the product, or bad about the or I'm feeling um, unsatisfied about this product. So in this sentence, we need to take care of whole sequence, like feeling bad about the product will be giving me the relevant information. So the review, the classify review could be negative here, and we need to identify these kind of tasks generated from the transformer based models. The checks generation is the place wherein we need to find out what is the next text based on the given context. So GPT-2 transformer modeling techniques can be applied here as well. NLP tasks, couple of NLP tasks are also directly solvable through transfer learning methods provided in transformers. One could be a named entity recognition, wherein you are supplying the text and identifying what are the prominent entities existing in those texts. The summarization form, translation, and QA-based systems that have been also built. So how the transformer models are basically solving these different NLP tasks is because these transformer models have been trained on huge content, maybe Wikipedia content or some sources, some open source contents, which is in GBs of data. So once they have been trained, like they internally have acknowledged those information, and using that information, basically when we are providing we are using for a couple of different NLP tasks, we are getting a good results out of it. Okay, so these are the couple of various transformer models that we use. This is a BERT wherein, as I talk about, for mask language modeling, we will be supplying single sentence and mask out couple of tokens, and the outcome is the labels, like what is the prediction for the mask label. Here we are supplying two sentences, so sentence 1 and sentence 2. So this kind of architecture we are using to predict the next sentence. So if one sentence is predicted, another is getting predicted. Now there are various versions of BERT available in there, wherein one is that distilled BERT, wherein we need to reduce the number of parameters so that it can be faster enough for the processing part, and we can be used in real-time systems. So in distilled BERT, it's based on the phenomena of student-teacher learning, wherein what we have is like the teacher is having more knowledge and is providing the distilled knowledge to a student. So using the pre-trained BERT, after distillation, we have reduced a couple of features. So this is one of the method that we used in most of the tasks here. Another good model, which is T5, quite prominent these days, like which is based on multiple different problems, solving multiple problems through one single model. As you know, like if I provide information as a translate English to German and give that data to a transformer T5 model, like I will be able to get the translation out of it. Or in other case, if I have given a command as summarize this particular content, so T5 will take that and give me the summarized history. And on other hand, if I have need to ask couple of queries, like the rhino grazed on this grazing field, and if we need to ask a couple of information out of it, then T5 also is able to give me that. So T5 transformer is text-to-text transformer, the recent one that people are using for multiple different NLP tasks combined in single modeling technique. OpenAI GPT-3 is another model which is based on causal modeling. These are a couple of links that have been used that can be used to find more information on these transformer-based learning models. Now, these transformer-based learning models require one more important concept, which is called the subword embedding. Now, in the traditional approach, what we have is like we were having the embeddings generated, but with those embeddings, the main problem was like if we get out of vocabulary word, we will not be able to handle that. So subword embeddings are the recent concepts which are used to solve those purpose. So it relies on the principle that frequently used words should not be split up, but rare words should be decomposed. So what they do is like what we want is like the words which are coming most number of times, we must not be split that up. So BP is one byte pair encoding technique proposed in 2015, which is basically pre-tokenization. And then based on the frequency of each word, we will be merging those words until the vocabulary size is attained. So for subword tokenization, for subword embedding, we specify what is the maximum vocabulary size. We get the data, and then based on each token, we identify, and based on the frequency, we will be again merging that each of different words if based on the frequencies. Byte level is including all characters that are quite large, so we use the bytes instead of each character values, possibly used in GPT-2 and Roberta models. These are the transformer-based models. Word piece is another improvement on the previous one. In contrast to BPE, word piece doesn't choose most frequent symbols. Instead, it chooses that maximize the likelihood of data. It means like it will choose those words which are coming together. So it will take the likelihood of words occurrence and used in BERT and distilled BERT. Unigram is another way wherein we start with the base of vocab of large number of symbols and then progressively trim down. Sentence piece is the new one released by Google. All the previous algos, so it inherently assumes that we previous stages in previous algos, we assume that the space is used to separate the words, but it is not valid for all the languages. So sometimes we treat this input raw stream and can be used for subword embeddings using BPE or Unigram or algorithm. Okay, so once we have that, what is the main use of these transformer models? So these transformer based models can work in two different tasks. Like we use the already trained transformer and use that for fine tuning our models. This is one way. Another way is like we build the transformer model scratch on our own data, because my data is maybe different to what the model has been trained on. So three different ways people use these transformer models. So what we have used is in couple of use cases is like one big use case is mart item tagging, wherein you have the mart items and you want to predict the tags out of it. Like let's suppose if I have um, uh, Coca-Cola 500 ml as a product name. Now the category could be beverages and subcategory could be cold drink. So we need, from the text, we need to identify what kind of categories and subcategories are. So what we have done is like we use those textual content and feed in to a transformer model with some additional deep learning layers associated with category and subcategories, and fine tune those transformer based models and build our final predictive modeling specifically for mart item tagging. In address parsing, as you know, like what the problem is tells me, like we have a given address in textual format. Let's suppose 145 Mulberry Drive, New York, 10013. So what we need to identify is various constituents of the address, like house number could be 145, or the road could be Mulberry Street, zip code is 10013. The city is New York and state is New York, NY. So with this, what basically we want to use is like once we have the address constituents extracted, we need to validate the address, specifically used for most of the use cases of shipping a particular parcel or delivery cases, food delivery cases we have. So address parsing plays an important role there. So these kind of use cases can easily be solved by learning transformer based modeling techniques. So main advantage that we got here is like we are doing away with the feature engineering part of the stuff, and then utilizing and asking model to learn those feature automatically. Okay. Yeah, with this, I would end my talk. Thank you very much. Thanks a lot.
Thank you so much, Ritesh, for your wonderful session. And we are looking forward to work with you in our next conferences. And I'll
Yeah,
ask the audience that if they will be having any question, they can ask you in the Q&A session or in the chat. Okay.
Thanks
you.
a lot.
Hello, Mofik, how are you?
Great, how are you?
I'm good too. Thank you so much for asking. Okay, Mofik,
Awesome.
my name is Serena, and ladies and gentlemen, now with us is Mofik Eddy, who is working as Microsoft Azure Data Scientist Associate from Ordo VHF. And Mofik, thank you so much for being here as a keynote speaker. We are honored to have you. So you can start your presentation now and kindly share your screen with us.
Of course. So the pleasure is mine. Hello, everyone, and thank you, Serena, for the brief presentation. Now I'll share my screen with you, and we'll start my talk.
Sure.
So I think by now you can see my PowerPoint presentation.
I can see your slides now. So Ritesh, sorry, Mofik, you can start your presentation. The stage is all yours. Good luck.
Okay, thank you so much. So my talk will be about deep reinforcement learning using big data for stock market prediction. And you can see this is not a classical trading algo modeling. Well, it's gonna talk about a lot of aspects that is trending today in the AI and data science community, as well as in the financial industry community. So the table of content, we're gonna start by talking about algorithmic trading. It's separated in two parts, and then we're gonna talk about big data in algo trading. This is the novelty, how to use different sources of information to form your big data and then put it in use in algo trading. And after that, it will be our idea of how to model the data to use it for day trading. After that, we're gonna have a conclusion and perspective. And during the presentation, if you have any questions, feel free to send a message or just open your mic and ask me, no problem. Or after the presentation, I will make sure like I leave 10 to 5 minutes so everybody can jump in. So let's start. Algorithmic trading, we're gonna start by an introduction. So algorithmic trading is a type of quant trading, and we always hear in movies and TV series, and even in our professional lives, how quant is and has changed the financial industry. And it's when we are talking about quants, it's like one of the high on-demand jobs that you can find in banks, insurance companies, and any financial industry. And so in algorithmic trading, which is a type of quant trading that uses pre-specified machine executable instruction to determine the size and timing of trades based on quantitative model of asset price behavior. So in here, what we want to say is that algorithmic trading in the 70s and 80s and even in the 90s, they used to use static models and some probabilistic equations to have an edge on the financial market. So what the algorithm that you define does not learn and evolve by itself. So you see the data, if it's like linear, you use a linear equation. If it's not linear, you use, for example, stochastic equations to try to beat the stock market. That's the classical thing to do. The next part is algorithmic trading using machine learning. So machine learning is an old field of AI. It's not new, but it's gaining hype and momentum during these last 10 years, and the applications are really big. One of them, of course, is in the fintech industry, and specifically in the trading field. So machine learning involves algorithms that learn rules or patterns from data to achieve a goal, such as minimizing a prediction error. So instead of having a statistical equation and being confined by the boundaries of, for example, linear equation or stochastic equations that does not evolve through time and does not reshape itself depending on the data. Now with machine learning, we can have, we will not define the equations by ourselves, but we're gonna feed the data to our models, and then we're gonna get a dynamic result. A result that's gonna change depending on the market movements. So machine learning algorithm can extract information from data to report or automate key investment activities. So if we are talking about trading industry, it's not only specific to day trading, but that's always the hot topic. And that's always the step into this industry, is to just try to manipulate some day trading algorithms. So these activities include observing the market, analyzing the data to form expectations about the future, and decide on placing buy or sell orders. So basically, our objective is to know when to hold and when to buy. We can trade EFTs, and now there is the concept of NFTs. We can do it with cryptocurrencies. We can do it for bonds and equities. We can do it for a lot of different things. It's not always buying or selling Apple stocks. So these algorithms can be applied and taken advantage of in different variety of financial instruments. And after that, after trying to place and buy sell orders, as well as managing the result portfolio to produce attractive returns relative to the risk. So it's more about risk management. So if you invest $1 million, you want to have more money, like significantly more money. So there is a big risk side of this subject. So machine learning in trading can minimize that risk and can make the benefits and the returns even bigger than using classical equations to beat the stock market. And now most, for example, if we are talking about stock exchange, especially in the US, most of them are not based on statistical rules. It's more powered by AI and executed by bots instead of human beings. Which brings us to the next step, which is big data and algo trading. So when we talk about the US market, we have a lot of sources of information, and the market is really subject to the political events, the economical events, to the climate, even in change in political movements in other countries and other international organizations. So the big flux of information cannot be processed with the old ways of having equations, even the complex equations like we heard people are using in big hedge funds. They will not give you the expected return we are talking about today. So for big data, for financial trading, data sets reflect the myriad of decisions taken by market participants. And that's why I was talking about a lot of market participants from where we can get a lot of information. According to Herbert Simon, actors begin their decision-making process by attempting to gather information. In today's world, information gathering often consists of searching online sources. So you can go to a news channel, you can watch even videos and analyze them, and you can do that through robots. Like you can analyze the human behavior, even the way I'm talking. You can make a deep learning model that can detect my feelings when I'm communicating this kind of information. And if you do it for a government official, like a president of a state or a senator or something, you can know if he's telling the truth, or you can know his bluffing, for example, which will affect the market, the financial market. Therefore, the sources of information are not just tabular data. Now we have multimedia type of information. So in today's world, information gathering often consists of searching online sources. Recently, the search engine Google has begun to provide access to aggregated information on the volume of queries from different search terms and how these volumes change over time via the publicly available service Google Trends. So Google Trends is an amazing tool to keep track of how much people are searching for a specific company, and you can see that trend using Google Trend. If that company is on hype, whether it's good or bad, you can figure that out. But it's not, with Google Trends, you will not find if it's like positive or negative. And that's why we're going to integrate other aspects to try to analyze if the data we have gathered will positively impact our models or not. So the second part of talking about the big data is what we have discovered and what we try to implement recently, which is wide and deep learning. So all of us know is one of the biggest institutions in the world that have great teams working on artificial intelligence, and one of them one of those teams have implemented what they call deep and wide models, wide and deep models, to build their recommendation system engine. So if you read the research paper, which I have included in this presentation, you will find that wide and deep learning is used for Google recommendation system, especially in YouTube. So we have thought about taking advantage of that. So we're going to gather different sources of data, which is our tabular data and multimedia data. and we're going to use this concept to try to model the data we have. So we're going to start by an embedding, which is a translation of a high-dimensional vector into a low-dimensional space. Ideally, an embedding is capture of some of the semantics of the input by placing semantically similar inputs close together in an embedding space. So the first step is to gather that big data and which present a high dimensional space and squeeze it into a lower significant dimensional space. We can think of it as a feature extraction, but that's not the exact concept. And the embedding we're going to have is going to have dense information that we can process to get better results. So if I have, for example, 1 megabyte, one gigabyte of data, and I will try to analyze it. Many of the information provided within that space will not be that useful. So we can dance all that information into a lower dimensional space, which have more significance. And then it's our challenge to take advantage of what's usually used in language modeling in our time series. So language modeling, which is like, for example, NLP, we can use NLP to, and that's what we did. We analyzed the news articles with NLP to know the sentiment of the article. So if the article is talking about Google and I analyze the news article, it's gonna tell me if it's like positive or negative. And then I go to Google Trend and I see if the searched Google term, Google company term is on trend or not. So with Google Trends, I will know if that company is going on trend. If it's like a positive trend, I will know it through applying NLP to news article. That's the concept we're talking about. So this is the first work employing gradient boosting of deep models with embedding in the context of time series forecasting. So when we are talking about trading, it's always about time series forecasting. But before doing that, we need to make the embedding, and then we need to extract Google Trends data about the company, and then we need to know the sentiment behind the news article we have scraped, which at this point, everything was done and it was feasible. We have scraped the data, we have scraped Google Trends and the news articles, and then we have run our sentiment analysis, and we made our judgment between the news and the articles. And the previous statement proves that we can embed our, so embedding is usually used in NLP, but we can take advantage of that in time series. So the information that we have extracted, now we're going to apply time series on it. Once we apply time series, I'm going to put this here. So for the wide models, here it's more about Google Trends, what Google Trends is going to give me. And these wide models, we're going to memorize which companies are going into trend these couple of days, and then it's going to give me the positive and the positive or negative sentiment about it, which is wide models. It's more about generalizing. But then the time series aspect is going to be used, is going to be modeled through deep models. So I put my dense embeddings in here, and then I apply time series to it. So in here we are talking about scraping data, scraping news, scraping Google Trends, applying NLP to news articles, compare to Google Trends to know the exact sentiment and the volume of the search key. So these 4 different steps is just for wide learning, so the model can memorize the current trend. But then for generalization, it's from my tabular data and other data that we put in a tabular format, and we have embed to to a lower dimensional space. Then we're going to apply, that's what we did. We have applied deep learning to, we have applied time series through deep learning to get relevant forecasts. So there are a lot of aspects to it, and one of the sources that we have gathered is how many people search about an SAP Fund 500 company on Wikipedia. So the search trend about companies in Wikipedia is really valuable, but that was between 2010 and 2013, which was the research paper. But after that, we have enhanced our dataset with trending company names on Twitter. We embed all those informations and then we apply time series to it. Why we do that? Why we use embeddings and deep learning with the wide learning? The deep learning will help us generalize the decision we are making. So with wide learning, we are memorizing the current trends, and with deep learning, we are trying to generalize what we are currently learning, which will really help with making accurate predictions. And as you can see, this heavily based on big data analytics, which is a huge step before making our final data set and feed it to our deep learning model. So these are not speculations. It was based on research paper have been done in many universities that I will share with you at the end of the presentation. And we try to collect the best practices from each one, and many of them were applied to a different field of trading. So we tried to integrate them into our novel model. Now, what is the big novelty in this research? Until now, we have made the wide learning part and the deep learning part, and we combine them together, and we have our wide and deep learning recommendation system for buy and sell in trading. But the challenging part, which we currently researching and we're trying to implement, which is of course is an ongoing effort, is the deep reinforcement, is to integrate our wide and deep learning into reinforcement learning. And as you know, reinforcement learning is a big topic in research. So for now, we did not implement our deep reinforcement learning architecture, but that will be our next objective. So what is deep reinforcement learning? It's the combination of, so deep reinforcement learning has two different fields. We try to combine them together, which is the reinforcement learning and the deep learning. The field of research has been able to solve a wide range of complex decision-making tasks that were previously out of reach for a machine, like winning Go. Everybody have seen I'm assuming that most of the audience have seen DeepMind algorithm that have beat the Go champion. And that was a deep learning model, and the algorithms are called AlphaGo, AlphaZero, and the best one was Mu0, which is something extremely ordinary. So my inspiration for this research, at least for deep reinforcement learning, is still a research for me. I have no implementation for it. It was from that movie. Like I was like, if we can apply to Chogi, Atari games, chess, and the Go game, board game, we can definitely apply it into trading. One of the most notorious algorithm is the A3C, implemented by DeepMind. That's like a gem, one of the biggest gems of this industry. So A3C stands for Asynchronous Advantage Arithmetic, was developed by Google DeepMind. We know that Google has acquired DeepMind. And A3C consists of multiple independent agents with their own weights who interact with a different copy of the environment in parallel. And the last phrase is the most interesting phrase, because in the trading, we have different sectors: oil and gas, metal, tech, health companies, many sectors. And some sectors will correlate. So when I was watching, reading the research paper, I was like, if A3C models can interact in different parallel environments, we can make, sorry, I'll put it in here, we can have a global network. So this is the architecture for A3C. So the global network have different workers, and each worker is assigned for a different environment. So the smart thing to do in trading is that each different environment will be a different sector. And all of them will report back to the global network with their finding in that sector. And the global network will propose the next steps and for the other environments. So in here, we are not talking about all the companies in the stock exchange. We're gonna put them in different groups according to their sector, and we're gonna run the wide and deep reinforcement learning algorithm. The half of it we already talked about in the previous slides. And in every sector, we're gonna have a worker on the environment that will give me some predictions. And all those sectors will communicate back through global network. So if there is a correlation between the environment, I will take advantage of them. And the great thing about A3C, it can like find hidden patterns that are invisible to human beings and that we cannot with our classical machine learning or statistical equation determine by ourselves. It's like a game. We're gonna use the wide and deep reinforcement learning to get new patterns in the financial industry through the different sectors. And like we know, each sector has a subsector to it, which have different companies. So we can even use it for feature extraction, like we can know new features and we can analyze further the behavior and the correlation between different companies. And this is the complex part, which is still a research thing, at least for me. But from the literature, a lot of projects are going on in a big financial industry trying to implement. And we heard on the news that some hedge funds have successfully done similar stuff. But the novelty in here will stay that we are using advanced big data analytics to feed our wide and deep learning models that we're going to integrate it in A3C. So the next step for us is the integration to the A3C. And by the way, this is a personal project. And I will try to explain the model architecture that we have come up with. So in simple words, and you can follow what I'm saying, reading those paragraphs, big data analytics sources, we have focused on Wikipedia and Twitter to get Wikipedia, Twitter, and Google Trends to get what we have previously talked about and to construct a rich data set. And then we have used financial data for the trading. We have scraped like the basic data that, for example, Yahoo is providing for free. But we have integrated other aspects, and we even tried on the Tunisian market. Since I'm a Tunisian national, my first experimentation were with the Tunisian market, but then I shifted to try my models on New York, on the US companies. After that, we have tried to integrate all these different resources to construct our wide learning models, and we have embed through deep learning what we have learned so far, and we have applied time series on it. And then the final step, like you can see in here, is to use wide and deep learning with reinforcement learning. So the reinforcement learning will enable me to have different workers to work on those different environments. So ladies and gentlemen, in here we have combined big data analytics data scraping, and we have analyzed all of those, and we have implemented our wide and deep learning models. The next step is to put that in a global network, in a global reinforcement learning network, and let our workers in different environments discover what we have in separate regions. So the reference for this work, it was based mainly on these research papers that you can see in here. And on the top, you can find my GitHub. It's a very humble GitHub repo. Well, I'm currently trying to put my findings and what I'm doing. You can see all my GitHub repo where I have other repos for scraping the data, analyzing the data, putting some algorithms and models. And hopefully after a couple of months, I will try to put all of those together, but still you can check it right now, as you can see. And for the reference, you can always go back to them because they were cornerstone in this research and hopefully in my future implementations. If you want to connect with me and talk more about the subject or if you want to collaborate with me, I will be really glad to hear your feedback and ideas. You can simply go to my LinkedIn. I'm always responsive and I will be happy to hear from you. Thank you very much.
Thank you so much, Mofik, for your mind-blowing presentation. We are delighted for your time and participation. Thank you so much, and we are looking forward to work with you in our next conferences.
My pleasure.
And I'll ask the audience that if they are having any question, they can ask you in the QA session or in the chat session. Okay.
Of course.
Thank you so
Of
much.
course.
Stay safe. Have a
Thank
nice
you.
day.
You too.
Thank you. Hello, hello, Subhadev. How are you?
Hello, hi Anna, I'm fine.
My name is Serena, and ladies and gentlemen, here Subhadev is with us, and he will be presenting now. He is working as a principal data scientist at Ericsson. So, Subhadev, thank you so much for joining us, and we are honored to have you as our keynote speaker. So you can start your presentation now and kindly share your screen.
Sure.
Thank you.
No, I'm sharing my screen, but it's not happening. I don't know. Let me just try once more.
You just need to click on the green button at the bottom, share screen button.
Yeah, but the share screen, the share option seems like it is not working.
Okay, so can
I
you
don't know
please?
whether.
Okay, can you please share your slides with us so that we can play it for you?
I can do that.
Sure.
It is a moment. So where shall I send this slides?
To Anna.
I'll do one thing. I think it might be the problem might be this is my office laptop. So let me just go back and start with the same thing in my personal one. Give me some more.
Okay, sure.
So what I'll do is that I'll sign off from this link and I will join the same link again from the same mail
Okay.
from my personal one.
Sure.
Okay. Thanks. I'll join just right now.
Hello.
Hello, Subhadeep. So are you
Hello.
able to share your screen now?
I'll just try.
Okay.
Just
Sure.
try once. Give me a moment, please.
Sure.
Give me a moment, please.
Sure. Take your time.
I don't know why it's not happening.
Okay. Okay. Subhadeep, if you want, you can send us your slides, or
I'll
if you
just
want, you can present without slides.
I'll just send my slides right now.
Okay. Thank you
Right
so
now I'll
much.
send the slide to Anand.
Sure.
Okay.
We are waiting for you.
Yes. I'm sorry everyone for this delay,
No,
but I
it's
didn't
okay. It's okay. No issues.
okay. It's Anna Morgan at pgsols.com, right?
Yes, that's right.
Okay. Something happened. Please note I have shared. I've um, sent the slides right now.
Okay. Okay. We are just checking it.
Hello, have you received that?
Yes. Yes, my colleague is going to play it for you.
Okay. Okay.
Yes.
Yeah,
So
I
if you want, you
think there
can
was some.
start your presentation.
I'll do that. Just give me a moment.
Okay, sure.
Okay. Hopefully, yeah. So what I'll do is that I'll follow up the same screen. If you can if you can show the presentation, then it will be easier for me to go through, and I'll can request to change the slides.
Okay,
Yep.
sure. Can
Okay.
you see it?
Thanks. Yep, I can see it. It should be fine. First of all, I'm sorry for this glitch. It was like and unanticipated. I didn't think that it might happen. But anyway, first of all, thanks everyone for being present here, and thanks the organizer to invite me to share this knowledge. And I'd like to discuss a bit on the type of modeling and analysis that can be done in a big data enterprise scenario, and how simple approaches can actually address a class of problems. So the title of my talk is Survival Analysis, Event Prediction and Enterprise Big Data Applications. So it's necessarily application of survival analysis, but a little bit intelligent and novel way, so that it can address a class of problem. Can you please go to the second slide? Yeah, thanks. So when you say events, what is an event? An event is actually an observable occurrence of a state of a system. For example, if we consider a system like the stock of a big retailer, then out of stock may be a event which is of importance to the retailer. In similar way, for any engineering firms or factories, malfunctioning of machines, or for patients related studies where a patient is being followed up under some medication or clinical trials, the onset of illness or mortality of patients, those all are examples of events. So we can say that in general, by suitably defining events, we can actually understand certain behavior of a system, which might be very important or useful from the business perspective, or maybe just even from the learning perspective. And the common question that we usually are interested in case of such event defined properly is when the next event is going to happen, or maybe just like the chances of the event to happen over a period of time. Typically a profile, a probability profile of the event of being happening in future. And this particular question can very naturally addressed via survival analysis. It's also known as reliability engineering, and based on survival analysis approaches. So what essentially is being done here is like we model the rate of event occurrence based on the historical event sequences that we observe, and also based on the covariates that are available with the data. Now let us consider some enterprise use cases that actually are related with such an application. For example, healthcare, CPG, retail, or online retail, or telecom domain. In every such enterprise scenarios, we can actually define and identify events.
It's 4:30.
So that the related business questions can be addressed. For example, in healthcare, the time to onset of next illness is a very important event, because it can actually let us understand how a preventive medication or preventive elderly care can be activated, or maybe even it can reshape the whole insurance domain. Actually, it's being done in heavily in the insurance field, whenever a premium etc. are being calculated for an individual or a group of individuals. In the same way, the retail or online retail scenario, the onset of next out of stock or the onset of next lull sell period is also of very importance, because out of stock, if not addressed in time, can harm a lot of the reputation and of significant financial loss. Similarly, the lull period sell can be actually energized by proper application of promotion, etc. And in telecom domain, to keep the continuous customer experience and consistent customer experience and consistency of service, we need to know actually where certain kind of events like some alarms or anomalies are appearing for the different mobile sites from where the mobile calls are being controlled on an overall basis. Hence, when we define an event properly, it can actually address a lot of practical aspects and can do a great impact to a consistent kind of business run. Okay, next slide, please. Thanks. And the connection of such problems with big data scenario is really big, because in modern businesses, whenever we are dealing with large organizations, be it a large retailer or be it a large telecom company or be it a large healthcare company, these events that we are interested into, when we want to make a practical usage of that, it translates down to a typical big data application scenario. For example, in retail, we have millions of items and thousands of stores and minute level transactions, and our interest might be at item store level out of stock scenario. We just want to know which item in which store is going to be out of stock, or what will be the status of out of stock in next 7 days. Depending on that, the whole supply chain actually is being activated. In the same way, in telecom scenario also, we have hundreds and thousands of sites, the mobile sites, the big towers, through where all the calls are being handled, and there will be thousands of events of our interest. Like, for example, when the site is going to be in a dormant mode, or when there will be an interruption due to increase of traffic, and so on and so forth. And hence, when we want to translate down to an actionables, it will be actually a model prediction, model building at thousands and thousands of in numbers. Hence, typically, what we will be doing is that we will be dealing with a big data scenario. Next slide, please. And as I mentioned, the event is really important when defined in a intelligent way. As I already mentioned that, I'm not kind of repeating this slide, but what I'd like to say is that in all these scenarios, the problem that we want to solve is we want to predict the next event occurrence, or we want to find out what is the event probability profile for next maybe a week or maybe a month, whatever may be relevant to the business questions. That means a cleverly modeled or a cleverly created solution for event prediction can actually lead us to address a huge class of problems that is spanning across different enterprises. And hence, the leverage of such solutions can be deep in impact. Next slide, please. Typically, this is kind of a graph of sales of 2 items, and the out of stock scenarios are identified with the red circles in the bottom. So what we want to predict is that, given a current time point, for example, if our current time point is say at 400, then we want to predict those little circles that is lying beyond 400 on the right hand side. Typically, what is the chances of this out of stock to happen in recent future? And in a similar way, we can just kind of make a parallel with all other industries where a suitably defined event and hence probability of the event to occur can address a class of problems. Next slide, please. So I have actually created this presentation by keeping a close contact with this out of stock scenario study, and whenever there is a parallel, I'll draw that parallel with respect to other enterprises as well. For example, for an out of stock use case, there will be different sources of data like inventory data, transaction data, and promotional data. And inventory data, which is being the typically supplying the response variable, giving the out of stock status. The transaction and promotion data actually will give us the covariates, the relevant covariates. In a telecom scenario, there are thousands of KPIs which will actually serve as the covariate for us. Similarly, for a healthcare domain, the demographic details of individuals or a group of individuals can give us the relevant covariates, and the response variable can be defined as per the definition of the event. Hence, typically there will be multiple sources of data, and again paving the possibility of using all the big data solutions here. Typically a distributed database and related Hive and other technologies to build all these models, or rather to build the data for all these models to make them work in action. Next slide, please. Oh, thanks. And now let me just draw a parallel to event prediction and survival analysis correspondence. So event prediction is typically a generic case of a survival analysis scenario. In survival analysis, we are interested to when the next mortality or when the next machine failure is going to happen. A generic extension of that is when the next event is going to happen. And we are actually interested in the survival probability easily be connected with the next event occurrence probability by defining suitably the events. For example, if we define in stock or active sale, like the mobile hubs which are working for us, those may be active or maybe dormant time to time. If we define active state or a healthy state of a patient as 0, and the other events occurrence as 1, like for example, out of stock is happening is 1, or a dormant and sleeping mobiles hub is happening is like 1, or a illness has onset and define that as 1, then we can bring the survival probability model and we can just make a transfer to by subtracting it from 1 to get the next event occurrence probability. Note that this relation depends on the way we are defining it, and in most of the cases this relation will hold, because in most of the cases that the way we are defining the events are like reverse in what we do in survival analysis. Hence, our objective is to leverage the survival analysis techniques for predicting the next event. Next slide, please. Just the core essential terms. I have kind of not included any deep math for the general audience. So what we are doing is that we are defining something called hazard, which is nothing but the limiting value of event to happen in a very thin slice of future time, given that time has passed till small t. Hence, we are observing we have observed all the data till the time small t, and we want to know what is the chance that the event will happen in next delta t or dt time interval. And when we make it as a limiting scenario, what we get is called a hazard function. And the whole objective of survival analysis is to arrange the data and do the modeling for this hazard in terms of covariate and time. So that ultimately, once we model hazard, we can go and figure out what is the cumulative hazard, and the survival function can be shown as exponential negative of this cumulative hazard. Thus, in nutshell, once we start modeling of hazard function and estimate the cumulative hazard, we have actually the survival function for that defined event. Just to make a analogy with all the existing cases, we can say that this the survival function can be connected with the probability of a cell entering a shipping mode, or the next alarm is going to happen at after time t, or next battery failure happens at type t. In this way, like just defining the events in a proper way and arranging the data to fit in a survival analysis model, we can easily figure out what is going to be the expression for our probability of next event. Next slide, please. We have explored quite a few models here. The most normal model being is Cox proportional hazard model, and there are and random survival forest model. So in Cox proportional hazard model, we have some concept called base hazard, and then there is another part which actually consumes all the covariate data and figured out what might be the and let us estimate the hazard function. In random survival forest, there are trees, and the trees are being like the random forest. We also fit here the decision trees for modeling the hazard function, but there is the basic difference with usual random forest model is that in this case we do the splitting based on a log rank statistic, and this log rank statistic is being derived from the log rank test. The details I can share if deeper if there is any need of going to the deep technology. Please connect me. I'll just share all the relevant references. Now, when you say a baseline model, like we want to figure out how this survival approach is actually helping us. For that, we have created baseline models where we are regressing the length of the out of stock happening given a time point to next nearest time point, and this response is being modeled as regression on all the available covariates. We have used random forest, quantile regression, and Bagot for as set of baseline choices. And we have experimented with weighted and unweighted models, where weights is being inverse of 1 plus molar resistance of the individual data points from the center. Next slide, please. Covariates are typically, give me one moment, please. Covariates are typically the related to the business use cases. For example, in retail, we can have this promotion related information or out of stock and different features of those items that are being sold as the inventory, as our covariates. And in telecom domain, there are thousands of KPIs, for example, uplink and downlink throughput, or signal strengths, or the physical resource blocks, or a handover success rates, etc., as a covariates. And in healthcare, various demographic data of the patients and initial medical conditions of the patients can act as important covariates. Next slide, please. Yeah, so this is a very interesting slide. Here, actually, what we are doing is that we are just transferring the whole data that are observed into a format which can readily be consumed by a survival analysis setup. So typically we have item 1, for example, we have sequences of whether there is an out of stock happened or not. And this is some time, at some time granularity, it may be equal interval, it may not be. So for the time being, just consider they are equally interval. Maybe some every 15 minutes we are getting an information that whether there is a out of stock or not, maybe at daily level. Now what we are doing is that if there is an out of stock, we are considering that as 0, and if there is a if there is an in stock scenario, then we are considering as 0, and if there is an out of stock, we are considering as 1. And whenever there is a run of 1, we are considering that as actually occurrence of an out of stock, and we are replacing that run of 1 by a single 1. So what it will do is that it will transfer the whole data into a generic survival analysis consumable model. Why is that so? The reason is that once there is a out of stock scenario, then it will continue for a while usually, and what happens during that time, that there is no information further is available, and that sequences of 1 is not giving us any additional info. Just like in a survival analysis, when you are studying the mortality of a patient, a mortality has happened means there is an information, and that's the information about the patient. Until and unless it is a sickness, there is not going to be any further kind of a observation of sickness. So for example, if we consider the sickness happening as 1, then there will be a starting of a sickness, and that will continue for a while, and during that information nothing is going to help us, because it's only sickness or not sickness kind of scenario. That's why changing the run to a single observation is actually making the whole data consumable for survival analysis. There is another concept of censoring that I will discuss in the next slide. So once we do that, then we recalibrate the time, and hence a sequence of such data can lead us to a tabular representation as included in the below. So for the item 1, if we go on observing item 1, then typically the third time point, which is actually a clubbing of 4 consecutive out of stock occurrence, is going to give us an information that there is a out of stock that has happened, and the consecutive gap between these out of stock incidences are 3, because started from 0, like we started observing no out of stock, and then there were 2 consecutive days of out of stock, no out of stock, and then the out of stock happened, and it remained there for 4 days. And that 4 days we clubbed, we have 1 occurrence of out of stock run, and then we have I have 1 observation. Hence, since the beginning, there is a interval of 3. In this way, we rearrange the data and make it consumable for survival analysis application. Next slide, please. This is the way we are just connecting. Can you please go on tapping, because there are certain yeah. Hold on, please. No, previous one. Yes. So this is how we are transferring the whole sequence of data into a slide, into a tabular data, and hence connecting them after the recalibration. Next slide, please. Yeah. So typically, what is going to be the output? The output is going to be what is the chance of the event. Like in this case, what is the chance of the out of stock in consecutive next 7 days or so. Actually, what is being done is here is that the probability is being calculated for next few days, and unless there is a plateau, we just go on calculating the whole thing, and we stop when there is a plateau of the probabilities. Hence, typically we have seen that for next 10 to 20 days there will be changes, and then it will become a flat kind of thing. Hence, given a time point, which is the current time point, we find out what is the probability of an out of stock for next 20 days consecutively, and there will be the estimated. I have included graph. I'll just show. But before going to that, let us just give a quick view on the validation approach. How we are going to validate it? Actually, what we do is that we do validation in a little different way. depending on the business use case, we define a probability threshold beyond which we say that, well, actually the out of stock is going to happen there. For example, if there is a fast moving item, then we may give a lower probability threshold, say 0.6 or so, and define that whenever our estimated probability for out of stock is greater than 0.6, we'll say that, well, an out of stock has happened. And actually that time point when 0.6 probability is being considered will be is being observed will be considered as the onset of the next out of stock. So from current time point, which is 0, to when we are observing the threshold of that probability has appeared, that we are considering as our observed time period for out of stock from the current time point. And for every data point from the validation data point, we know that for a given time period, what are the expected days for next out of stock. Hence, we can easily compute the differences of what we are predicting and what we are observing. Next slide, please. So this is typically how the probability profile for an out of stock looks like. As I mentioned, the x-axis is the time in days and y-axis is the out of stock probability, and hence there are items which are kind of quickly reaches very close to one kind of probability in very early days, like within 10 days or so, which are fast moving, and there are items which actually slowly moves and reaches to some reasonable amount of probability to get that out of stock happen. This way, I have just predicted output from two different model. One is the Cox model, and another is the reliability of forest model. Next slide, please. This is the way this is exactly the threshold that I have mentioned. So when we are defining a threshold, say for example, a threshold of probability 0.8 beyond which we will say that the out of stock is going to happen, we have seen that there is the over prediction for that particular time period. That means in many of the cases out of stock has happened earlier, but we are predicting that out of stock our predicted our considered threshold is actually translating down the time to out of stock happen is more than what we are observing. Similarly, when we put P as low as 0.5, there are under prediction. That means out of stock is happening earlier than when we are later than what we are saying out of stock will happen. For example, in this case, if we decide that the threshold is 0.5, then out of stock might happen around some date 14 or so. And actually, this might be an under prediction because out of stock actually may happen little later. So now all the experiments, whatever we have done, we have seen that experimenting with these probability thresholds around 6.6 to 0.7, it gives good results. That means the validation, whatever we are doing, we get lesser errors. Next slide, please. So this is the metric for validation for performance measurement, as I mentioned. So this EI is the expected time to event for a data point I, which has kept as a validation data point, and Y is what is the same. We are defining, we are first estimating the probability profile, then defining a threshold, and then finding out what is the as per the threshold when the out of stock is happening from the for the particular data point I, and that particular length Y is our EI is that expected length, and Y is the observed length for that particular data point. And relative difference of EI and Y expressed as percentage with respect to the observed is giving us the right metric to compare how different models are working. We are considering mean of the above metric over the validation data set. And there are some other ways also, other schemes also we have tried out where they have considered asymmetric kind of metric. That means if we consider out of stock kind of scenario, then if we predict little early that out of stock has happened, that will probably save a lot of loss than predicting it late, whether it has already happened. So predicting late can be penalized more than predicting early, and hence we can get a kind of a measurement of the error metric also. Next slide, please. The censoring part that I have mentioned earlier. So what happens in reality is that there might be some replenishment has happened before the out of stock has happened. For example, for the item 1, though the first out of stock started happening at time point 4, and after 4 consecutive days there was again again in stock, but before the next out of stock happened there has been a replenishment at time point 11. So that replenishment actually, if we this type of survival analysis approach can easily accommodate this replenishment as a censored observation. Why? Because we are observing the in-stock scenario, and before the in-stock scenario transferred into out of stock, a new fresh this thing has happened, and hence there we could not observe naturally what would have been otherwise. That means us censoring in terms of the data that we are observing. There has been a censored scenario. That means the original run of the in-stock was obstructed by an external factor. This particular aspect actually is a huge advantage for any kind of enterprise scenarios where there are interventions that happens without any prior knowledge. For example, in-stock kind of thing can happen like that, or there are services that may happen for different mobile towers, right? There might be different type of software services that are happening which can address different alarms. So before the alarm happen, actually there will be an intervention, and that kind of scenario can easily be accommodated using the censorship in the reliability model. And this is where the reliability approach is giving us a great kind of advantage. It is letting us to accommodate a natural phenomena which otherwise is not that straightforward to accommodate. And due to this this particular view, we saw that our model performance increased a lot. Next slide, please. This is a simple comparison. Please note that we have considered here only 2, COX and random forest or reliability forest thing. Why is that so? Because COX, proportional hazard model, and reliability forest model both can address the censoring scenario. The performances of these two was far better than the other baselines. And this under this 0.3 or 0.3 and 0.4 appearing with the model, actually the way we are penalizing the under statement rather than over. So 0.3 is a penalizing factor for the metric when we are validating for the understatement, and 1 minus 0.3 means 0.7 will be the overstatement penalization for the overstatement. In this way, we are actually we can play with these tuning parameters and the individual models at item location level, or models at telecom at site and vendor level can be tuned to a great extent for superior performances. Next slide, please.
It's 5 o'clock.
Okay, so there are 2 unique advantages of survival analysis. One, I have already mentioned that the way we can address this censoring depending on different enterprise situations, like for telco or for healthcare or for a retail, with the proper definition of the censoring, the accuracy can be enhanced to a great extent. And another is a typical comparability of different models. For example, if we have 2 items and we know that item 1 is actually a big ticket item and it has actually even one item missed due to out of stock for item 1 is a huge loss, then we can from this probability profile figure out what might be the scenarios so far as the replenishment situation is concerned. For example, maybe at 10th day, the chance of item 1 to go for out of stock is little over 0.4, whereas it is little below 0.6 for the item 2. But item 1 is being very big ticket item. We can actually prioritize the item 1's replenishment. There are many other calculations that can be done depending on the loss. We can add actually loss metric for item 1 and item 2 and very nicely determine a data driven in a data driven way what might be the right time to prioritize for item 1's replenishment versus item 2. That means a strategic decision making to the inventory management kind of problem will be far more easier if we apply this reliability based approach across all the items, or at least the items which are moving and which are important to the retailer. The same way for a telecom or healthcare, depending on the type of events, to what extent they are important, we can prioritize the strategic action. For example, there might be different types of alarms for different mobile serving sites, and one type of alarm may be far more deep impacting than other, and from the probability profile of those alarms we can determine, well, maybe the alarm 2, though it has lesser chance of happening on 3rd day but is being much more important, we will prioritize this alarm 2 kind of proactive address rather than working on the alarm 1. So this is the most important aspect for the application of the reliability based modeling. Next slide, please. Yeah, now the big data scenario, how we are scaling up. Actually, we experimented with many items, like 47 items, 1853 locations, and we have figured out that 38,331 item location combination was actually significant to model, and other locations were either were dropped either due to incomplete data or insufficient amount of data to create any model per se. What we figured out that the median error was like 28%, and both the models like Cox proportional or the random reliability forest model, both were kind of competing. This was a 10 minutes time taken, but it was a normal user in a Hadoop cluster, so we didn't actually make a note of the number of serving nodes that time because it depends on the load itself. But the way we did the experiment, it seemed like scaling over thousands of items is not an issue so far as the modeling is concerned. There are few other aspects we need to consider because this is an automated kind of deployment, so we need to have a fallback options. So in this case, fallback options can be like naive based estimate based out of stock estimation. That kind of simple model can work always, so that the whole the running of the models might not get affected due to a few odd scenarios where we are facing some problem of doing the modeling due to data or whatever other scenario. Next slide, please. The next steps will say there are many different ways of leveraging this. We can introduce the mixed effect model kind of concept in this scenario, so that we can even go till individual item level variations modeling also through a random effect being introduced the right way. And there are sparse data scenarios for which better calculations strategies can be derived. But overall, what you can say is that the event prediction kind of approach can actually address a class of problems, and that can be very useful for different enterprises in a big data scenario where there are lots of newer mobile sites can come, where lots of newer sites like the items and different stores can come, and hence the complexity of modeling is ever increasing. In this scenario, this can be a helpful quick tool for us to do strategic decision making and also to have an insight about the way the business is running. Yeah, I'll say I'm done, and thanks for your patience. Probably it was little more than what I planned for. There is nothing as such, so all the rest part of the appendix which I would like to skip, and if there is any question, I'm happy to address right now or any other time.
Thank you so much, Vadim, for your wonderful session. It was very interesting. And I'll ask the audience that if they're having any question, they can ask you in the main stage, in the chat session. Okay.
When the chat session, how can I attend the chat session? It's just like clicking the chat will
Yes.
kind of okay.
The window
Okay.
will open in front of you. Okay, so thank you so much for being here as a keynote speaker, and we are looking forward to work again with you. Have a nice day.
Sure. Sure. So for sharing the slides, let me know, because I can share a slide. This version probably has a lot of additional slides which is not required. So if you want me to share the site, let me know. I'll just share a version which will have only those which I presented mainly.
Okay, sure. Thank you. Hello, good afternoon, Pierre.
Hello, hi.
How are you?
Great. And the audience, I hope that they're great as well.
Yeah. Okay, so ladies and gentlemen, Pierre is here for the presentation, and he's working as a data protection officer from Christian Dior. And Pierre, thank you so much for being here with us as a keynote speaker. We are honored to have you in our conference. And I can see your screen now. You can start your presentation.
Yep.
Stage is all yours. Good luck.
Thank you very much. Yes, it was very interesting to be part of this conference, because when the organizers came to me, the idea was to go through any notions related to AI, machine learning, but from different horizons. So we just got, for example, very technical details about how best to cope with that. And earlier during the day, you got already some legal matters to deal with. No worries, I won't go through further legal details. What I wish to do with you is to really browse some material up to date with regard what to address, for example, back to your businesses, what could be sorted as a good AI and a bad AI. So we'll go through some examples, and to give you some fresh flavors of ongoing legal developments. I won't give so much details about legislation, because I don't want to overflow you with some of these details, but it's good to keep them alive in our mind, just as a reference for the future. So that was an interesting topic, how to actually browse some good and bad orientation with regard machine learnings, ethics, and AI. So I tried in this preparation to go through different examples and best and bad practice. So let's go for it. A little virtual icebreaker game. You surely recognize on the right side some works of fiction, either books or movies. And actually, what I tried here is to address some notions on the left and to link them onto the right. So it's interesting to see that human beings are really aware about artificial intelligence, because they even make movies about that. And they are perhaps a little bit afraid of what it could entice. So if we go through the different fictions, 1984, Minority Report, Space Odyssey, or Ex Machina, well, basically the notions that you have on the left could be, it's a proposal because some of these have different ones, but my proposal would be that one. In Ex Machina, you have advanced robotics taking part. 1984, you have mass surveillance. A Minority Report, of course, you have precognition on judicial decision. You're not guilty, but you're already guilty, basically. And Space Odyssey, well, the AI is basically doing some self-decision making, even killing people on the spaceship. So yes, AI is in the works of fiction kind of the very bad evil we want to kill. But let's go through actually the reality and what's in our lives. AI or machine learning, these are at very high level. You surely know that already because you're all experts, but it's actually good to, you know, take a step down, not too specific, and to browse through different actions or realities that people, you know, your neighbor, your friends, etc., will actually recognize. Closer to your lives, artificial intelligence could be used, I'm not saying it's automatically the case, could be used in job candidate review. So if you're applying to a job, your CV is screened, your different results in tests are screened, and they are compiled as per some criteria, factors, and then a mark, a grade is perhaps attached to your profile. So it can be your background, your present works, or it can be as well your results in tests. It can be as well your credit and loan review. So you're applying to a credit at a bank, you wish to buy a car, or you wish to buy a house, or a remote mansion on an island in the Pacific Ocean, surely. Your entire life will go through some, you know, washing machine, so to speak, in order to make a decision about whether the bank or any credit agency will give you the benefits of that loan. We can talk as well about that's the central triangle. We can talk as well about consumer profiling. So I know that several of the businesses present at this conference might do so at some stage or another. You all have clients. And if you work in the retail area, you might have some processes that will compile behaviors, compile buyings, sales, in order to issue some statistics or to issue some points of reference as per which client is really good client and which client is not, you know, so interested in all products. So that could be one element for your businesses. And then, of course, you browse the internet, you get cookies, you get, you know, habits, behaviors on what sites you browse most of the time. If you browse 20 websites on Formula One or sports, or currently the Tokyo Olympic Games, well, you know, some artificial intelligence set by whoever said it could specify, okay, Pierre is really interested in the Tokyo Olympic Games, so perhaps we could come back to him and sell him some tickets for the next Olympic Games in 3 years' time. Why not? As I was saying, if we go back to this little pyramid, job candidate review, your profile may depend sometimes, and that's the bad side of it, understood from that slide, may depend on your ethnicity, age, gender, places or education you've been through. So obviously, if someone sets the machine learning or the artificial intelligence to detect the ethnicity of your case and declares that this and that ethnicity is no good for recruitment, obviously we here are in a case of discrimination. Same for the age and gender, for example, or if you come from a college that has no real good reputation compared to other colleges or high schools, when there will be as well differences in the candidates, and therefore the recruitment is not fair and transparent. As I was saying, consumer profile or browsing experience, these are actually compiling habits on the what. When you went into a shop, what kind of shop, where, in what country, or if you browse internet, that would be, what sort of sites, for how long are you browsing different sites? Is it for 5 minutes or an hour and a half? Which terminal, on your smartphone or computer? So basically here in blue, we could already foresee that the two little triangle in blue, these are decisions made on you without your clear control. You hand over some information about you because you're requested to, because you're interested in something, either to get a job or to get a loan, and your entire life basically is compiled and profiled. So you don't really have a say. They are legal processing to stop, to object, but you don't fully know, you may not fully know what's behind. And the one in gray, consumer profiling, browsing experience, well, this is, a true profiling process of information that you provide knowingly. I mean, you will get into buying experience or you will get into browsing experience because you're doing so live, factually speaking. Now, let's go a little bit inside the what could go wrong, actually. There could be many things, but I don't want to really go on that, slope and road where, we pinpoint every bad instances. I try to select two basic examples. So on the little diagram, you can see the terms hidden, so lack of transparency, unpredictable, you have no control. You as a consumer, user, or subject of this prediction, or basically that's the bigger wheel. You have, or somebody in the company setting the machine learning didn't set human interaction to actually stop or to gain control back in time should, the process go a little bit beyond what you expected from such processing. So if we turn to the left side of the slide, what could go wrong? Well, these are, my things, my thoughts. You might have other example in mind, absolutely, depending on your horizons. But to me, example number one, you could go through an absence of control leading to an unstoppable process. So it's exponentially learning and going beyond to the borders, the settings that you set. There is no switch button, meaning that you as the initiator of the AI and the machine learning, because you had in mind surely a business perspective to do so, you didn't set within the design of this process something that could say, don't stop, we are doing a cleaning of that process and we issue new settings and new rules. Actually, I like to speak in AI and machine learning about rules. It's like a rule that you enter into a programming solution. One good example would be that the profiling activity on your customers continue despite the fact that these customers raised you their point saying, I want to object, I want you to stop, I don't want you to further process my information into profiling activity. And if in the design you haven't set, we will go through a little bit in the details in the next slides. If in the design of your process you didn't set that, it could be a huge drawback for your company because you could be in breach of different legislation. Example number 2, a little bit like the other one, but more on the amount of private transparency, that you set vis-a-vis your clients, customers, meaning how far, to what extent are you diligent in making sure that what you write in your notices, statements is the real truth, if you mention it at all. So for example, I go to a bank, I wish to get a loan, to obtain a loan. I'm giving lots of information, bank accounts, savings, whether I've been, already in trouble, financially speaking, and so on and so forth. Even, results from health testing to see whether I'm, a danger for the loan. Well, yes, the documents will be used to assess on your viability vis-a-vis the loan, but perhaps this information could be shared to other third parties, and you might not be aware of that. So if you use AI, machine learning, generally when we talk about profiling and these sort of things, it is important to keep in mind to be transparent, because the lack of transparency might play for you, for your business for a while, but at some stage, it will go back like a boomerang. Then, what I wanted to give you further to these 2 or 3 slides, not the doomsday slides, but rather to give you some what could be sources in terms of fair use of the data that you placed into this machine learning and AI. Let's have a look at the right side of this bubble, the white boxes. You might actually set technical controls. You might set a good level of information. We just seen an example actually about this. And obviously, you need to design correctly the algorithm that will be part of the AI or machine learning. So if we shift a little bit to the boxes in gray, what each of these notions, principles that I just mentioned speak of, is basically you need to get an oversight on the machine learning. You cannot, set it free wheel and let it go, without any borders, without any control. It's basically a motorway where you have barriers, on each side. You cannot have a motorway without barriers. There should be inside these sort of controls a redress mechanism, meaning people can say, no, I don't want that anymore. Information, we just seen it. So data subject, customers. Customers know about it. You have also internally documented the purposes, the objectives of your AI and machine learning. They have a design purpose. What are they? To what extent? How long? Which teams are actually accessing the information that you collect and get an output from? So this is as well another control to establish a fair use. And obviously, I think the big part is if a regulator, an authority, like a surgeon, goes into the body and the inside of the AI and machine learning and how it was programmed, they might see that actually you've built in socially constructed bias, meaning, as we've seen this example in the pyramid, you might set that for this and that sort of people from this and that sort of background, well, actually will refuse their job application. or I will not hand over them a loan or a specific advantage. So either this is that case, or it can be the other case where your information that you've collected in order to build the machine learning and the AI are not accurate or adequate to what you want to do. So from the start, you have a good objective, you have a good solution, it's legitimate, you've set, borders and principles, but actually the information is not complete, it's not accurate. So basically you will place within the process information that cannot be used. So it's a bad return on investment on that amount. Oh, actually, sorry, I go back to that slide. If you want to go beyond, actually, everything from that slide is actually particularly detailed in a note that was established by the European Parliament. So you have the reference at the bottom of this slide. It's very interesting for making decision on what sort of principles you need to address in these sort of projects. Let you take note of it for some seconds. And then it is interesting to see that, yes, for the past few years, we've seen a growing activity from legislators and regulators in the privacy field. So you've surely heard about many privacy laws here and there in different countries in Asia, Europe, Americas. And actually, legislators actually in Europe are starting to issue a secondary law in terms of making sure that AI and machine learning are as well regulated as you would regulate the process and transfer of personal data. And the slide is about this. So basically, the review that I've done from a piece of legislation that will appear on the next slide is that you have two principles to take into consideration. Are you loyal to your users, to your consumers and customers? And are you vigilant? Do you care in the process that you've established? And if the answer to these 2 points is we don't know, or maybe yes or maybe no, well, you might not be in the right path. You might not be on the right road. Basically, loyalty speaks about the interests of your consumers come first. So I know that in some projects that you might have in your businesses, business teams might come to you saying, that's the interest of the company. Yeah, sure, financially speaking, it is. But fundamentally speaking, it isn't. It's the rights of the consumers first. And actually, in the different pieces of new legislation that will come, users are not only seen as consumers, but they are seen as citizens. So this notion may differ, I understand, from countries to countries, region per region. Citizen is not necessarily, for example, a notion that you will be hearing in the US. They will probably speak more about consumers. I might be wrong, but that's my assessment. Then if we turn to the vigilance principle, as we were mentioning, you should not be confident too much on leaving the computer doing the work alone. You should have a redress mechanism. You should have a switch off button. And your methodology, because you need policies and methodologies, should contain regular reviews. And actually, if you take the two bags, loyalty and vigilance, the two buckets, you have actually the results of what you have from the data protection law in Europe, GDPR, a specific recital, which is actually at the very top, recital number 4. And it's interesting to see that even 6, 7, 8 years ago, the EU legislator in Brussels was already mentioning the fact that the processing, any sort of processing, AI, machine learning, etc., should be designed to serve mankind. So I like that quote. It's not necessarily having a huge impact on business teams, but actually what it says is exactly what's inside in practice of the two buckets. So if you have these points and further, actually you should be okay in this notion, to serve mankind. Remember 2001, the Space Odyssey, basically the artificial intelligence is trying to kill mankind. So that's why the example in the icebreaker. Then only the one and last two slides. There are interesting sources that we can have in this field. The UK Information Commissioner talks about, well, actually they have established an interesting AI guideline. So it's particularly interesting because you can have different notions and guidance with regard different aspects on how to build and implement AI. And actually it speaks to different members of your organization. So it's not only directed to data protection officers or experts, it's also addressed to different staff members in the IT departments or in the commercial business departments. And it talks about, concepts, objectives, how to design, what are the limits currently with regards AI and how it will be best used. So an interesting, if you can Google that, you type ICO AI guideline, you will obtain it. And then the piece of legislation I was mentioning 2 slides earlier, there will be a regulation soon. We don't know when yet, but I give you the last version, which is April 2021, so relatively recent. And actually, it's an excellent mix between how to use AI for the good of the society, including companies, businesses, and as well versus the balance for the users and consumers. And here, within that piece of legislation, we note again governance, loyalty. It should serve the interest of the consumers, but it also grow the single markets in Europe, optimize the operation of your business, and so on and so forth. So in a nutshell, I think we are, from a regulatory legislation perspective, there's a will to place real borders, place real guide rails to such activities, but the objective is not to prevent such activities from occurring. On the contrary, it's like, in any privacy laws, it doesn't say you cannot process personal data. Actually, it says the contrary, you can, but if you respect certain guarantees. So I wanted to actually address these points and feel free as well to go through this. I think the best takeaway is to go through these guidelines. They are really interesting, and by chapter, so you don't need specifically to read everything, but it's interesting to note already the concepts. And it's actually a guideline that was issued early July, so it's fairly recent, and I wanted to include that in that presentation. Overall, I think that's it for me. Thank you very much, and I wish you the best for the rest of the conference. Thank you.
So thank you so much, Pierre, for your wonderful session. It was very informative presentation. I personally enjoyed very much. And thank you so much for your time and efforts you took to share your expertise with us. And we are looking forward to work again with you.
Yeah, thank you.
Thank you. Have a great day. Okay, so ladies and gentlemen, as now we are at the end of the conference, and I would like to thank all the stakeholders, including delegates, speakers, and suppliers, without whom this conference would not have been possible. And I would especially like to thank all the speakers um, and for their valuable point of view. So I extend my best wishes to all of you. We will be back with novel themes in our next conference. Thank you so much. Stay safe. Have a nice day.